Okay, let's get started. So as usual, you can see my screen, and please go to the GitHub link and check out to this module 5, and then create a new branch for module 6, so you have the same progress as me. And one thing I want to mention, this is something I didn't cover in module 5, but I did on my own, which is I added several packages. I don't have much code changes yet, but I added a new package. But when you check out module 5, you have the same changes that I have. So one is river pod annotation, and then under the dev dependency, we have this river pod generator, build runner, as well as the customer lint and river pod lint. And I also added here for custom lint, and which is very useful. You will see in the later module we will use the river pod tool, where we can generate the provider instead of typing on our own. That's why we have this not this one. That's one. Here we have the generator, and this if you see the curriculum, here there's a course on the very end, the last module 13, we will migrate into the river pod 2.0 with the generator, and I was just doing experiment by the so as you will, just for someone anyone that is new, we are following code with Andrew's course, where I have purchased, so you don't have to buy. And this is not my course, but you can either buy and watch on your own or with me, and we can do together, or you can watch the video with me. But I cannot share the screen of the video course, but I will go through what is the code change and explain along the way, so you can see the code and you can code along with me to learn together. Okay, let's get started. So in today we are in the test. You see module, we are in module 6. It's the same, it's consistent, same as the branch name, same as the video name, module 6 for automatic testing part 1. And it's going to be a large module, and let's get started. And you can learn, you can hear what he said, and I will explain what he means, and then you will see the code change, and you can code along with me.
We will begin learning about automated tests in Flutter. And in my opinion, if you're serious about app development, then writing tests should be part of your development process, because automated tests help you ensure that your app works as intended. And as we will see, getting started with automated testing is relatively easy. But overall, there are many different kinds of tests that you could write, and we will learn all about them as we make progress. In fact, what we will cover could very well be a standalone course about automated testing in Flutter. And the best thing about it is that we will use our e-commerce app as a reference, meaning that we won't write just some random tests that have no practical use. But instead, our goal is to write tests that are actually useful and apply to apps that can run in production. And this will be based on the features that we have already added to our e-commerce app. And what is also important is that we will learn how to write tests for all the various kinds of components that we have included in our app architecture, both in isolation and taken together as well. So here is an overview of what you will learn in this section. To start off, I'll give you an introduction to automated testing, so that you can better understand all the reasons why we should write tests in the first place. And then we will learn about the kinds of tests that exist in Flutter, using this testing pyramid as a reference. And then for the rest of this section, we will focus exclusively on unit tests, as this will serve as a good foundation for the next section, where we will cover widget and integration tests, as well as some additional kinds of tests. with that said, unit tests alone will give us plenty of things to learn, including how to work with test matchers, how to mock dependencies using the mocktail package, how to write acceptance criteria using the given, when, then format. We will also see how to generate and report test coverage data directly in VSCode, and we'll talk about the test lifecycle methods, and we'll even learn about some advanced testing techniques and figure out how to run tests directly on GitHub Actions using a simple workflow that is triggered every time we push our changes. So let's get started on the next lesson.
Okay, so the video basically him reading some slides, right? So you are not missing anything. I hope you can hear clearly. Today we have quite a bit noise. I'm very sorry for that. But very soon, yeah, it's a lot of theories, but
in this lesson, I want to tell you why you should write automated tests and give you a better idea of what makes them so valuable. In fact, I can think of multiple reasons why writing tests is a good idea. Because by writing and running automated tests, you can ensure that your app works as intended. You can catch bugs early during development when they are cheaper to fix compared to when the app is already in production. You can avoid regressions when making changes, as well as refactor with confidence, and I'll prove this to you in the coming lessons. Tests also help you write better code in the first place, and another reason that may seem a bit counterintuitive is that they save you a lot of time, especially compared to manual tests, and I'll talk a bit more about it very shortly. But for now, let me focus on the main benefit, and that is that tests can be automated, meaning that we can repeat them as many times as we want, and even set up a CI system that runs all the tests every time we push some changes. But of course, there is also one disadvantage, and that is that we had to write the tests in the first place. And of course, this takes some effort. And just to be clear, if you're writing a super simple app, such as the Flutter counter example, then there is only one test scenario, and that is that the app should show the correct counter value when we press the increment button. So in this scenario, testing the app manually doesn't take long at all. But if we consider something complex, such as our e-commerce app, then there are already many different features that need to work correctly. And testing all these features by hand is very tedious and takes a long time. And just to give you a preview of what we'll be able to accomplish by writing automated tests, here is a short video of a single integration test that goes through all the steps needed to complete a checkout flow inside our app. And as we can see, this test completes in just a few seconds, but if you just imagine how much work it would be to complete all these steps manually every time you make changes, then it becomes clear that automated tests have a lot of value. And once you acknowledge that automated tests are valuable, then the next objection you may have is, but I don't know how to write tests. Well, that's not something to worry about, because we are about to learn how to do this. But of course, I completely acknowledge that writing tests takes time. So another goal of this course is to give you some sense about which tests are most valuable so that you can invest your time wisely. So once we have covered all the most important testing techniques, we'll also try to discuss what is an effective testing strategy. In fact, at this stage, I think it's useful to get back to our testing pyramid. And as we can see, this pyramid contains 4 kinds of tests. At the bottom, we have unit tests, which are generally used to test a single function, method, or class. And this makes them quite useful for testing things like repositories, data models, services, and controllers in isolation. And because we can test them in isolation, then we can more easily see if they work as intended, given various different inputs. And because unit tests are very fast to run, then we can write many of them. And if we go one layer up, then we find widget tests, whose purpose is to test a single widget. And in Flutter, widget tests are also quite fast because they don't need to run on a real device or simulator. And we will cover them in more detail in the next section. After that, we have integration tests. And these are normally used to test a complete app or a large part of the app. And in contrast to widget tests, integration tests do need to run on a real device or simulator. And this means that it takes longer for them to start and complete. And for this reason, we normally have far fewer integration tests than we have widget tests. However, one thing that I'd like to point out is that they're used to test the client app only, and they are not supposed to talk to a real backend. And this makes them still relatively easy to set up. And we'll also cover them in the next section. And finally, we have end-to-end tests, which test both the front end and the back end of our application, giving us an idea if the system as a whole is working as intended. And these kind of tests are more difficult to set up and more difficult to maintain as well, because they depend on external factors such as network connectivity. And I should mention that we are not going to cover end-to-end tests in this course, because our focus for now is on the Flutter front-end only. And finally, I should also mention that at the top of the pyramid, we have manual tests, which need to be performed by a human rather than a computer. And we all know that humans are much slower and less reliable than computers. So as we make progress, we will try to figure out which kinds of tests we can use to test our e-commerce app. In summary, the big takeaway of this lesson is that automated tests are a useful tool that you can use to make your life easier. And I hope that by covering this topic in depth, you will come to appreciate how useful they are, and you will put them to good use in your own apps. Okay, so let's continue on the next lesson.
Okay.
In this lesson, we're going to get started with automated testing. And as we said, we'll begin with unit tests, which live at the bottom of our testing pyramid. And unit tests are the easiest kind of test that we can write, because they don't depend on the UI. And this makes them ideal to test anything that is not a widget, including controllers, services, models, repositories, and data sources.
By the way, if you follow my video, you don't check out this one. You check out my own for module 6, because I will have slightly different progress as his progress. And it looks like, yeah, this one is still a series. Let's just listen.
So let's get back to VSCode, and if you want, feel free to grab the starter project that I've included in this lesson so that you can continue from where we left off. And next up, I propose that we get started by testing the repositories that we have created, such as the fake products repository, as well as the fake auth repository. And once we have covered those, we'll move on to test the controllers that we have added.
So now we move to the code, which is great. And he mentioned in the last module where we have created under the auth, we created, where is the auth? Yeah. Feature. Yeah, authentication. We have a fake auth repository, this one. As well as under the product data, we also have a fake product repository. And my version has more commented code. It's some I will clean up, some I left just for the notes where we know how things get changed. But I will clean up. You can delete if you want.
Previous section, such as the AccountScreenController and the email and password sign-in controller. And as we will see, these are slightly more complex in that they depend on our repositories. And with that said, we can get started with the fake products repository. And the first thing that we want to do is to create a new folder called test inside our project. And this is something that is automatically added when we create a new Flutter project. But I have not included it in the starter project because we didn't have any tests to start with. So make sure that you create an empty test folder at the root of the project. And if we wanted, we could create our first test file directly inside it. However, let me point out that it's better if the folder structure inside the test folder matches exactly the folder structures that we have inside lib. And rather than creating all these nested folders by hand, what we can do is to select our fake products repository. And then if we right click, we can select this option called Go to Tests. And once we click this, we get this pop-up here at the bottom asking us if we want to create this file. So
interesting. Oh yeah, go to test. Cool. I didn't know that.
Let's go ahead. And as we can see, we now have a fake products repository test file inside a folder that matches exactly the folder structure that we have inside lib. And one thing that I like to do when writing tests is to arrange the original file and the test file side by side, so that we can more easily reason about the code that we need to write. So we can do that by selecting the fake products repository, and then I can hold Ctrl when I select the test file, and choose the option to open to the side, like this. Okay, so let's continue on the next lesson where we will write our first unit tests.
Cool. Hope you can follow along and let me know if anything not clear. Leave me a comment.
We are now ready to write our first unit test, and the way we are going to do this is to remove this boilerplate code that was generated for us, because this is what you would use if you wanted to write a widget test. So let's delete this, and instead, to write a unit test, we need to call a function called test. And this takes a string argument, which is a description of what our test is supposed to do. For example, our first test should check that the getProductsList method should return this global list of products. And then we need to pass a function argument, which represents the code that will run inside our test. And inside here, we can declare a final products repository equal to fake products repository. And we can use the quick fix option to import this. And the next thing that we want to do is to call expect, which is a function that takes at least 2 arguments. And the first argument is the actual value that we want to check. So in this case, this is going to be products repository.getProductsList. And the second argument is the value that we expect, which in this case is kTestProducts, since this is the value that is returned from inside this method. So let's make sure that we import this, and this completes our first test. And what we can do is to run it by pressing on this link over here. And as we can see, we now get a green checkmark indicating that the test is successful. And this already gives us a very basic formula for how we write unit tests. And the idea is that we create an instance of the object that we want to test, and then we write a so-called expectation that we can use to check that when we call a method or property on this object, then it returns the value that we expect. And just to make sure that our test is doing the right thing, then we can go back to our repository. And for example, here we can change this method so that it doesn't return the products list, and we can make it return an empty list instead. And if we run this test again, that this time we get an error.
We don't have a get product list, which should be here. I'm not sure why I deleted.
Telling us that we expected a list containing all these instances of product, but the actual value is an empty list. And of course, this is easy to fix because we just need to make sure that this method returns the correct value. However, one thing that I'd like to point out is that this error message is not very helpful because it's not telling us what values are actually contained inside each of these instances of product. And to understand why that is, we can open the product class, and we can see that this class does not implement the toString method. However, this is quite easy to fix because all we have to do is to use the Dart data class generator and add it.
So we want to go to the product data model, which is inside the product folder under domain. So one thing I really like is all the feature related profile is in the same file, and this one we need to generate into a toString. So you need to download this plugin called Dart data class. Now you have the toString. We get to be clear, we are doing, you can read here. So read function, we get the product repository. When comparing custom class, we must implement the equality operator. And we should also implement toString. So that's why we want to compare if this equals this. That's kind of interesting because this function will get a list of fake product, which is the test. I can't see why it's not going to be equal. I mean, the code is very clear, but that's the unit test.
toString implementation. And then we can save this file, and we can try to run this test again. And as you can see, now the expected values are a lot more descriptive. And that is because the expect function can now use the toString implementation that we have provided when reporting any test failures back to us. In fact, in addition to the toString implementation, it's also good practice to implement the hashcode and equality operators. And we can do this easily by selecting any of these properties and select this option to generate the equality operator. And now that we've added this, we can save this file, and then we can get back to our products repository and we can restore the correct implementation for this method. And then we can save this file and run this test once again. And as we can see, we get the green check mark once again.
Yeah.
In summary, we have now implemented our first unit test. And one thing that I strongly recommend you do with all your model or state classes is to implement the toString and equality.
We get a mistake. Let's try again. Maybe I shouldn't press that wrong button. The test wrong. So expect function will take two parameters, dynamic, actual and matcher, and we want to what's going on? It's supposed to be having a green mark, green check mark.
As this will make your life a lot easier once you tackle more complex testing scenarios. And by the way, I want to mention that at any point we can open the testing tab in the sidebar, and this will show us all the tests that we have included in the app, along with their status, and we can also run them again from here. And as we add more tests, this becomes quite handy, as we can run all the tests individually, all together, or even filter them by name. And you should know that you can also run the tests from the terminal by typing flutter test, just like this. Okay, so let's continue on the next lesson.
He said we can also do from terminal and Flutter test. See, it said because e-commerce app depends on Flutter web plugin, which doesn't exist. Version solving failed. Interesting. Let me stop for a while. Okay, so we had a bug and I fixed. I will show you how did I fix. So the warning says some list plugin the version conflict. I think I accidentally added this, so we just remove, and you can see I have run the test which got passed. You can click here to run or here to run. So that's for yesterday. We did this test, and today let's continue with the next session. This one, test marker. Listen.
In this lesson, we are going to get some practice writing more unit tests. And in fact, the next thing that we're going to do is to test this getProduct method. And what is more interesting about this method is that it should return a non-null product if there is a matching ID, or a null product if a given ID can't be found. And in practice, this means that we need to write two tests to.
So this one, we are still testing this repository, but we are testing this function to see if this function will return a product that matches the ID.
For this. So let's go ahead and write the first one. And over here we can add a new test, and the description should be get product passing 1 as the ID, and this should return the first item. And then we can add the test body, and just like we did before, here we can declare a final products repository equal to fake products repository. And this time we can expect that when we call products repository dot get product passing 1 as the product ID, then we get k test product with index 0. And the reason that we expect this to be true is that if we open the definition of the
return first item. And so we get this product dot get product 1, and we should expect the list product, and we expect the first item like this. Second one, we test if the product is not found, we get a null. But if you open this, the first item is ID 1, the last one is 14. Yeah, that's what we are doing. It should pass.
a test products variable. We can find that the list item at index 0 has a product ID equal to 1, which is the same argument that we pass over here in the test. And in fact, we should be able to run this test, and we can see that it succeeds. But instead, if we pass a different product ID or a different index and run the test again, then we can see that this time it fails. And it is good practice for you to try to read and understand these errors, because
it's failed. Interesting. So product ID 1. What? We expect to get the product ID 1. Okay, so we can read the
obtain the information that you need in order to fix your tests or your code. And here we can see clearly that we expected a product with ID equal 1, but we got a product with ID equal 2, and these are clearly not equal. So let's fix this by restoring the correct product ID, and then we can run the test once again. Next up, we can write a more interesting test, and that is that when we call get product with an ID of...
Wait a second. It's not passing, so we need to fix the bug again. Why it's not correct when we are indeed testing what's this? Let's try this one first. Probably get product. Instead of state error. Okay, so because we use the first where or no, maybe let's try this one. Sorry. Okay, let's continue, and I have fixed the bug. As you can see, the test passed. So what happened is, if you read the code here, and it says expect a function and return this. So because if you see, the expect is a dynamic, two dynamic actual matcher. So when we were doing a function like this, right? It's wrong. It will not get the product. So we should directly call the function which will return the product, which will match the first item. The second is the same. So you expect to call this function, and you expect to get a null, and this function will return a null. Yeah, so this is wrong. Okay, just to clarify why I have two functions here. In Andrew's code, he used get product. He used this function, right? You can see it's quite long, and the try and catch is easy to miss, because if you, let's say, this function is, it's not good, because even if you forget the try and catch, it doesn't show any error, but it can have error. So we don't want to use this one. I can delete this. So what I use is this one. First word or no. It's just one line, right? So okay, we can continue. See, it's not that easy. You just follow the video. There are things unexpected, and that's why we are fixing the bug here.
100, then this should return no. And in this case, we can declare our final products repository, and then we can expect that when we call products repository.getProduct with a value of 100, then we should get null as a result. And then we can try to run this code. But as it turns out, here we are getting an error message of bad state no element. And this happens inside the Dart collection package in a method called listMixing.firstWhere. And in fact, if we get back to our fake products repository, we can see that this is the method that we are calling over here. However, the way we intended this method to work was to return no if a product couldn't be found for a given ID. But if we read the documentation of firstWhere carefully, we can scroll down and find that if no element satisfies test, the result of invoking the or else function is returned, and if or else is omitted, it defaults to throwing a state error. So as it turns out, the firstWhere method takes an optional or else argument. And this is a function that we should be able to use to return a default value, which in our case is no. However, here we get another error telling us that the return type null isn't a product, as required by the closure's context. And the reason for this is that since this is a list of non-nullable products, then the or else function should also return a non-nullable product. So this doesn't really work for us, and this means that we need to remove the or else argument and figure out a different approach. But before we do that, I want to show you something interesting, and that is how we can test that a certain method throws an error or exception, which is something that is very common and quite useful. And the way to do that is to use a so-called matcher. And the way that this works is that inside our test, rather than expecting no, we can type throws. And as we can see, here we get a long list of options. And all these options are also called matchers, which are some special objects that can be used inside a test to check that the expected value is of a certain type rather than a specific value. And in this case, the correct matcher to use is throws state error. And if you open the definition of this symbol, then you're taken to a file where you can find a list of all these different matchers. And the reason I'm telling you all these things is that when you write tests, you shouldn't be afraid to explore the documentation and dig into the source code for these methods. In fact, this is a great way to discover useful methods and APIs that will make your life easier. And in fact, sometimes using a matcher is a lot easier than trying to compare values directly. In any case, let's get back on track. And here we can try to run our test once again. But as we can see, we still get the same error as before. And the reason for that is that as soon as we call the getProduct method, then we get an exception right away. And to understand why this happens, we need to notice that this expression is evaluated immediately before it is passed as an argument to the expect method. And the solution to this dilemma is that whenever you're calling a method that is expected to throw, then you should put this expression into a closure by using this syntax. And when you do that, then this closure will only be evaluated when the expect method is executed. And this will give it a chance to catch the exception and compare it using this matcher. And as a result, we can now run this test once again. And finally, we get a green check mark. So once again, to avoid frustration in the future, every time you have a function or a method that throws, then you should make sure that you pass that function inside a closure rather than calling it directly. And if everything I said sounds a bit confusing, you can head over to this page on my website where I explain this problem more in detail. And you'll find that the proposed solution is to either use a closure, like in the example that we have just seen, or if your function doesn't have any arguments, then you can use a so-called tear-off, where you pass the function directly as an argument without calling it. Okay, so let's get back on track. And one thing that I want to point out is that while our test now succeeds, it's not doing what it's supposed to do, because we said that we wanted to get a null value when we call this method with this argument and not get an exception. And we're going to see how to address this in the next lesson.
Okay, next lesson will be here. We already did that, right? Fixing getProduct, this one.
As we have seen in the previous lesson, our test is now passing, but it's not doing what it's supposed to do, because we said that we wanted to get null when we call this method with this argument and not get an exception. And this means that we need to change the implementation of our method rather than the code inside our test. So let's take a step back and restore the previous test code by expecting that this code returns null. And instead we can focus on the getProduct method. And since we have clarified that the first where method will throw an exception when it can't find an item, then what we can do is to wrap this into a try and catch block. So let's add this, and then we can move this statement inside the try block. And inside the catch block we can simply return null, like this. And if we run the test again now, we can see that we now get an exception, and instead we got a closure that returns a nullable product. And that is because if this method is supposed to return normally without throwing an exception, then we should just call it directly and remove the closure-based syntax. So let's remove this, and then we can run the test once again. And as we can see, this is now green. And this means that this method now behaves in the way that we want. And we had these two tests to prove it once and for all. And this is very valuable. And we have also learned something very useful along the way. And that is that the syntax that you should use is different depending on whether the method that you're testing returns a value or throws an exception. Okay, so let's carry on. And I should also point out that down here we have this watchProduct method, which also uses firstWhere under the hood and also suffers from the same problem of throwing an exception. So it would be good if we could refactor this code into a separate method that can be called both from here and from here. And this method should take a list of products along with an ID as argument, so that we can call it from inside this map. So over here we can add a static method that returns a nullable product, and we can call this getProduct with an underscore in front because we want this to be private. And then as argument we can pass a list of products along with the product ID. And then we need to implement the method body. And what we can do is to scroll up, and then we can select these lines from here and copy them. And we can go back here and paste them like this. And since this method is now static, I want to make sure that I call first_where on the list of products that is passed as an argument rather than the private instance variable that is defined at the top. So let's do this. And now that I have this method, I can copy its name and then scroll back here. And inside here, I can just return getProduct, passing the products list along with the ID, like this. And what I can also do is to copy this code from here, and then if I go inside the watchProduct method, I can make sure that I replace all this code with this new method call. And I want to make...
So, yeah, he's still talking about function here where we want to call the getProduct. It seems like this, right? So I'm just thinking, is it just oh, it should go from here, finish. So it's a private function where we take a list of product should be oh, it's correct, a list of product, right? And we say products. So here it will be products dot first_where non blah blah, and then we can use this in different places. So our product will be the fake products and product ID. And I should move this line to here. Let's add a comment. So we don't need this. So this is the logic will be reused basically. And we copy this into another place where we are trying to find the product. So it should be here, but this will be product, not a fake one. Okay, clear?
that I get from inside the map as an argument, like this. And now that we have refactored this code, we can go back and run all our tests again.
Okay.
And as we can see, they are still all green. And this proves that this
Let's try
refactoring
again.
has not broken the getProduct method in any way. And the fact that this calls this underscore getProduct method under the hood is just an implementation detail. And this allows me to prove another important point, and that is that automated tests give us more confidence when we refactor our code. And this is very valuable both for ourselves and other team members as well. Okay, so let's continue on the next lesson.
I'm not sure why he called this automatic test. It's not really automatic. Wait a second. The notes kind of confused. You see, we finished the video 6, but here we said grouping, but the grouping is second, so it's okay. Grouping basically means we are doing this. Add delay false. Refactor with confidence. That's what we were talking about. With two tests like this. These tests give us safetiness, meaning I just refactor. and here is grouping. Somehow the grouping is here. I'll just copy this from here. So you can see we have 3 test code. If I comment it, so you can see the difference. Then we get error again. Okay, maybe we added delay somewhere here. Okay. But you get the idea where we want to group this. To get a repository. Oh yeah. So it's the test code is the same. Make product repository, where instead of calling here every time, we create a function and add a delay and group these together with call we are testing the fake product repository. Okay, it's clear to me, but I think we can extract this method out, right? Like, it should be possible to do something like this, so we don't have to call this 3 times.
In this lesson, we are going to write some tests for these functions that we can use to fetch products using features of streams. And before we get started with that, I want to talk quickly about groups, which are a feature that we can use to group tests together. And the way this works is that inside our test main method, we can write group with a description such as fake products repository, and this takes a function argument where we can put all the tests that we want to belong to this group. So if we want, over here we can select all the tests that we have written so far, and then we can put them inside our group, like this. And as you can see, we now get an option to run all the tests for the entire group or to run them individually. So let's run this, and the results will also be reflected inside the testing sidebar, meaning that we can use groups to better organize our tests. And since this class is relatively simple, I think it's okay if we add all the tests inside one group. And as we will see going forward, we will use groups to our advantage. Okay, so let's go ahead and see if we can write a test for this fetch products list method that returns a feature. So let's scroll to the bottom over here, and then we can add a new test, and we can name it fetch products list returns global list.
We didn't talk about this.
And then inside the test body, we can create a final products repository equals fake products repository, and inside our expectation, we could write products repository dot fetch products list, and we can expect this to be equal to k-test products. However, this is not correct because this method returns a feature, and if we want to compare it with this value, and we can expect this to be equal to k-test products. A test for methods that return a feature is quite.
Okay, so now we want to test the one that returns feature. Let me first, so we are going to do this. How do we test a feature in a stream? It will be fetch product list, work product list. Okay.
Easy. And next up, let's add a new test for this method that returns a string. So over here we can add a new.
Okay, I will type this time. You see test. Always good to. This is for the stream. Interesting. I will save it for now to see if it's correct. Test again. This time we are doing return a global list, right? And we want to add async because it's make product future to call product repository, call this one. So fetch product list will be this function where we have a delay, and then we return a value of fake product. And when we try to test with the stream value, we call watch products list. We test this function where it's async. I think this is correct. Let's hope. I'm not sure, do we add the star to here or no, because it's for the stream. In this function, we didn't usually always yield only one value. Okay.
Test, and this test will check that watch products list emits the global list. And then inside the text body, we can create our products repository as usual, and we should expect that products repository dot watch products list. And in order to write what the expected value should be, then here we need to use a so-called stream matcher. And we can get a list of all the available stream matchers by typing emit, and this will show this list of options. And we will explore this in detail later, but for now the one that we want is called emits. And we can pass k-test-product as an argument, since this method will only emit one value. And if we want, we can run this test, and we can see that this also is green. So as you can see, there are some differences in the code that we have written for testing futures and streams.
So what he said is different. We will use this one to test for the stream with an emit function. Okay, we have practice, right, to see this. No, it's the same. Product repository dot watch product list. Oh, you're right. It's the same, but we are calling product list. Right. To see if it's correct. So this is the image function. Oh. So basically both are correct. So this one we get the stream the first value, and this one we emit this test. Interesting. You see, product is stream dot first. Okay.
When you test a feature that doesn't throw, all you have to do is to use async and await, and provide the expected value that you get when the feature completes. But streams are a bit different because they can emit multiple values over time. And for this reason, the Flutter test framework gives us a variety of stream matchers that we can use. And once again, feel free to peek into the source code to find out all the methods that are available. So let's get back on track. And as the next step, we want to write some tests for the watchProduct method, just like we have done for the corresponding getProduct method earlier on. So let's add a new test that will check that watchProduct with ID equals 1 emits the first item. And inside the test body, we can create our products repository. And then we can expect that products repository.watchProduct with an ID of 1 as an argument emits k-test-product of index 0. And if we take a look at these two lines and then we scroll up over here, then we can see that they are essentially the same, with the difference that this new test uses emits because this is a stream. And if we want, we can run this test as well. And as
this one is the same. Using emit function, and here we want another test, which is to test watchProduct 1. And we want to emits first item. That's what we are testing. So we still get a list of product. We will see repository dot. This time we are testing watchProduct function, right? So actually, I guess click 1, the ID is 1, and when we see image, we will say, okay, we want to get the first item for this.
See, this is successful. And finally, we can write the last test, and this will check that watchProduct with a value of 100 emits null. And then we can create our products repository, and this time we will expect that products repository.watchProduct with a value of 100 emits null. And this is all that we had to do. So this complete.
Okay, so this one, if we want 100, we expect to emit a null, right? And the description will be 100 emits null. I think we can also try to group these together. One, two, three, yeah. I'll just see, we can also use the group function. Group. I'll add description later. No. And we take the function. And the function will be our test. Again, we can remove the group. So we get the products. don't know why you don't do this one. It's kind of, why don't you get this directly? And we can say, my guess is these are testing fake one and these supposed to test real one, but we don't have real one, so we still use the fake one. Test future and string function on getting product. Okay, and we can run the group all together. Should be fun. That's a lot of testing code.
All the tests that we wanted to write to cover the methods in this class. And strictly speaking, we should also ask ourselves if we should write some tests to check that these providers do the right thing. But as you can see, there isn't really any business logic in here. And you can think of these providers as the glue between the widgets and the repositories. And all they do is to give us a way to access the underlying data. So in this respect, it's not really that important to write tests for these providers. And we will learn how to do this a bit later when we write some more complex providers that have some more logic in them. Okay, so let's continue on the next lesson.
Okay, the next lesson will be, add delay here.
Now that we are able to run all the tests that are needed for the fake products repository, I want to point out one thing, and that is that if we open the terminal and then we run Flutter test inside it, then we can see that the tests take a little time to complete. And that is because we have added these two calls to future.delayed inside these two methods. And while these are useful when we run the app, as they allow us to see the loading UI, we don't really want to have these hard-coded delays when we run the tests. Especially since this is a fake products repository that we use for testing purposes in the first place. So what I propose we do is to make these delays configurable from the outside, so that we can bypass them directly when we run the tests. And in order to do that, we can open our file explorer, and then we can locate the utils folder, and inside it we can create a new file called delay.dart. And then inside it,
okay, in the util function, we add a new file, delay.dart.
we can add a new function that returns a future of type void, and we can call this delay. And as arguments, we can add a boolean at delay, along with an optional positional argument that we can use to set our default delay of 2000 milliseconds. And then inside the function body, we can type if at delay is equal to true, then we can return a future.delayed, passing a duration with the given amount of milliseconds.
COD. It's the same. Okay. Seconds. Okay. Oh, my eyes hurting. What is else? Return future dot value.
Otherwise, we can just return a future.value, which will complete immediately. And now that we have this, we can get back to our fake products repository. And here we can replace this code with await delay, passing a value of true. And of course, in order to use this, we need to import it. And we can also copy this code.
So in the product list where we call the delay, instead of hard code, we say delay, await delay true, and we need to import optionally we can test the error, but we don't need only image.
And paste it in here. So all we have done so far is to create this function, which does the same thing as future.delayed, but with a more compact syntax and an argument that we can use to enable or disable the delay. But as we said, we want to make this configurable, and the easiest way to do this is to go at the top and add a final bool add delay property, and then we can make sure to add a constructor for it and move it at the top. And for more clarity, we can turn this into a named argument and give it a default value of true, like this. And what this means is that we can now
add constructor. Where is the constructor here? Okay, and the default is true, and this is option. So add delay, where we will say add delay. Yes, add delay. Well, we don't delete this one. We should have delete this one too. Right? Async. It's gone. So if we add these, we cannot get, we cannot use return, we have to yield. So this will be fine. And now this fake repository has add delay, and we say false. And here add delay false.
Take this property and pass it as an argument here and here. And the end result of all of this is that by default there will be a delay when we create the fake products repository without passing any arguments, but inside our tests we can change this behavior by passing add delay with a value of false. And of course we would want to do this inside all of these tests. So what I propose we do here at the top is to create a method that returns a fake products repository, and we can call it make products repository, and then we can use the arrow operator to return a fake products repository and pass add delay with a value of false. And as a result, we can now call this method inside our tests rather than calling this constructor directly. So let's copy this, and we can make sure that we use this method inside all the tests, like this. And as a result, we can now save the test file and run all the tests one more time from the command line. And this time we can see that they all completed much faster, in just 2 seconds rather than 14. And this is very important, because if we had thousands of unit tests inside a large codebase, then we want them to run as fast as possible. So as we make progress, we will make all our repositories configurable by making the delay optional, like we have done over here. And by the way, before we continue, I also want to mention that at the moment we are creating the products repository with this line inside each one of the tests. And you may wonder if there is a way to create this just once and reuse it in all the tests to avoid code duplication. And the answer is yes, and this can be done by using a test lifecycle method called setup. But for the time being, we'll leave this code as is, and we'll cover the test lifecycle methods later on. Okay, so let's continue on the next lesson. Now that we've added all the tests that we needed for the fake products repository, I want to take a short break and talk about how we can easily generate test coverage data in VSCode. And the reason test coverage is useful is that it allows us to see very quickly which parts of our codebase are covered with tests and which ones aren't. And as part of this, we'll also install 2 extensions that make it a lot more fun and satisfying to add test coverage to our project. And by the way, this is a topic that I covered on this article on my website, where you can find all the details. So let's get started by opening a terminal, and then inside it we can run this command, flutter test --coverage, and this will run all the tests as usual. But in addition to this, it will also generate a coverage report. So we can open the Project Explorer, and if we scroll up, we can find this folder called coverage with a file called lcov.info inside it. And if we open this file, we can find that this includes some test coverage data for all the files inside our project. And once we have this file, we can run some additional commands that will generate a report that we can open on a web browser. And I've explained how to generate this and included some screenshots of a sample test report in my article. But what is more interesting is that we can install 2 VSCode extensions called Flutter.
So it should generate this one after we run. Some test failed. Which one? It shouldn't be here. So the one we have is under test. We have this one. We are not doing these, so we can run this again. So we only test. See, maybe TestDownAll on here. I have no idea. What do you mean? This one is just test. Widget. It still referred to widget test. It's wrong, even though I commented. But and these are all fine. Or we have to delete the file for now. Yeah. So we delete the file, and now it's probably okay. Yeah, all tests passed, so you can see it generate this coverage. Interesting, but it's hard to read. That's why he said we should add an extension from here. Search for, there are two, Flutter coverage or this one.
Coverage and coverage getters. And these will allow us to see the test coverage right inside VSCode. So at this stage, I recommend that you open the Extensions tab, and then you can find the Flutter coverage extension, which you need to install, as well as the coverage getters extension, which you can find over here. And once you have installed these extensions, you can get back to the Testing tab. And as you can see, this now includes a section called Flutter coverage. And you can use this to drill down into all the folders and files inside your project to see how much coverage you have. And by default, you'll get a yellow warning icon if the coverage is between 50% and 70%. And if you can get this coverage above 70%, then you get a green check mark. And just to be clear, all this extension does is to use the test coverage data from the lcode.info file that we have generated when we have run this command. And this means that when you start a new project or open a project that doesn't have any tests, then you won't see anything in here. But as soon as you start adding some tests, then you'll be able to see the test coverage details in here. So this is how the Flutter coverage extension works. But what about the coverage getters? Well, if you pay some attention and you look at the bottom menu bar, you can see that there is a watch button. And if you click this button, then it will add coverage getters right inside your editor, so that you can see exactly which lines of code are covered with tests and which ones aren't. And the ones that are covered will use this faint dark green color, and the ones that aren't covered will use this faint dark red color. For example, we can see that all the methods inside the fake products repository are covered, but the corresponding providers aren't, which is exactly what we expect based on the tests that we have written so far. So as we make progress in the coming lessons, we'll make use of these extensions, as they will help us make an informed decision about which tests to write. And I recommend that you also use them in your own project. And before we continue, I also want to mention that it's a good idea to open the File Explorer, and we should locate the gitignore file. And if we scroll all the way to the bottom, then here we can add one extra line to make sure that...
Okay. So, GitHub, ignore, right? It means, yeah, because there are several ignore, I often get confused which one. So, why am I ignore is different? I am. So idea is just okay. Web. We don't need a web. Windows. Here is ignore. I didn't modify this one, but coverage /lcov.info, because this will be generated. So yeah, this will be the gray color. .in. He has more files.
Ignore the coverage /lcov.info file. so that this file doesn't show up in version control every time we make some changes. Okay, so let's continue on. Make sure that we ignore the coverage/lcov.info file, so that this file doesn't show up in version control every time we make some changes. Okay, so
I temporarily stopped because I was just curious. My version of GitHub ignore has different with him. Not a lot. Let me see. So we have lead, right? And we have lead, and we have the Android one. He added a few more, which I guess we will use in the future. But I can just add right now, even though we don't have the file yet. So one is Firebase exports. I'm just doing the same as what he had here. This will be another one will be .even .dev .pro.stake. Yes, stake, but stake should be first. From dev, stake, and we want to get some this will be environment variables, which we don't push to GitHub, and here will be Firebase local emulator exports. It's not in the video, but it's good to have. Here, ignore test coverage data. Cool. So I actually don't know this one. This is very interesting. I don't know how do you get this one. Let's read. Note on Mac OS, you need to have this installed on your system to use this. Interesting. Let's do it. Brew install. Yeah, you can do it on your own as well. So we are calling this function. Let me make it. May take some time. Cheers. So we install this, we can run this, and we'll generate HTML report, and it will look like from here you can drill into each directory, open each file individually. What's nice about it, all the relevant lines are color coded. Extension, it will appear on test tab. This extension will, a little watch button will appear, right? And what does that mean? If you click onto it, it will check the test coverage info in those files. We will going get this. Cool. And we already have this. Okay, we installed. Alone is not Writing test takes time. Oh, not nearly much. Okay. What I'm going to do? Yes. We want to test if we will get this file by calling this one. Nice. Open. Interesting. See, we have this one. That's cool. Ta-da! Our score is very low. But I actually didn't know this part, so it's very useful. Now we are going to number 10, test FakeAuthRepository. So we did product and auth.
Now that the fake products repository is covered by our tests, I think it would be a good exercise if we also added some tests for the fake auth repository. And this would be a good opportunity to reinforce some of the concepts that we have covered in the previous lessons. And we'll also learn more details about how to work with streams in our tests. So we can use the command palette to open the fake auth repository. And then we can open the Explorer to select this file. And then we can choose this option to go to tests. And we can go ahead
I don't know why this has this warning. Actually has this lowercase with underscore. Anyway, not that important. So I think we go to auth, lib, under feature, we down the products, and we are going auth. Authentication. And this is the one. Actually, there's a way we can open to say open to the side. Cool. And here, I believe we are going to go to the test. And we don't have the test, so we say create the test. You can auth and the test. Let's start.
And create a test file. And like we have done before, we can move this to the right panel. And now we can start adding some tests. So as a first step, let's remove the default test. And inside here, we can create a group called FakeAuthRepository. And then inside this group, we can write our first test. And what this will do is to check that the current user is null when we create our FakeAuthRepository. So inside the test body, we can create a final auth repository equal to FakeAuthRepository. And we need to import this so that we can use it. And then we can expect that authRepository.currentUser is equal to null. And while we are here, we can also expect that authRepository.onStateChanges emits null. And if we run this code, then we can see that our test succeeds. And this is what we expect, because the values that are returned by this method come from the in-memory store that we...
So it goes fast. I'll delete that later. So first, we call the group function because we have several things to test, and inside the group function, you see the ChatGPT doesn't give me good. Okay, so there are several functions we need to test. We are testing the FakeAuth, where because it's not widget test, which we will cover next module. Unit test will be just a test, and you add a description. Sometimes it's quite annoying with these autocomplete. Current user is null by default. And what we want is first we get the auth repository, and we will import. We get this, which is extension of this class. So this class has a function dot user, current user, default is null. So we expect current user and null. And we have another expect function. We also expect actual and matcher. So this one, we expect we're calling the change function, which we also because it's a string, we also emit null. I messed up, please. Maybe miss another one. Oh. To expect. Because the initial value is null here. Right. But what if we sign in? I'll make a note for now. Initial value is null. So the auth string will also be null. So I guess this will be run like what's happening currently before we sign in.
Created here, and this takes an initial value of null by default. And now that we have created this basic test, we can write some more interesting ones to check how these values change when we call the sign in and sign out methods. And before we go ahead, I also want to modify our FakeAuthRepository so that we can make this delay optional, just like we have done for the FakeAuthRepository. So over here we can add a final bool add delay, property along with a constructor that we can use to set this value to true by default. And then inside this method to sign in, we can remove this code and instead we can type.
Okay. Final, it's similar process. Add delay and add constructors. Don't need this. And usually he likes to put the constructor on the first line. Again, this is not required and it's optional. We give default value as true, and here for whenever put it smaller as far as you can see. So we say wait, delay, add delay, and this we will need to import. Okay, so we in our sign-in we have a delay. Create user, this one we also have a delay, but we need to await for the delay. Here, test. I should add delay to here. This is to test the error, but we still want a delay. Dispose we close. This is a create new user method. We take an email our state.value. Is here. This is in memory store that we created with a string function. These are from last session. I kind of forget. That's why I want to check again. So we were mimicking the Firebase auth string. So stream will be this. Value will be current user. Close will be dispose.value equal something. This will be a set. So we set a value. We create a new value to the auth state with email, and we don't add. We will add password later, but not yet. And here is user.register. This is something we will use later, where we get a list of users, because several people can register list to keep a track of all user accounts. But currently we only do one. Okay, should be clear. And we can read what's expected in this class. Here's the resulting code you can see. So we have a test email, password, test user. Oh wow, that's pretty long. Then we say add this. So in the main, we add this. App user is our class we need to import. is not after sign in. Auth repository dot sign in. Now you await for the sign in method. When you sign in, you say, oh, this is the email and the password. And in this time, you expect the current user will be the test user. Our string will be the test user as well. Basically, this is a value, and this will be a string. Interesting. Okay, so this will be the second test. Then we will add. So the difference is the first one we didn't call this function, right? Okay. It should be here. My question is, I shouldn't have leave. My question is about the password. Sign in with the password. We have password. Okay, we passed the password, but we didn't use. That's fine.
And pass @delay as an argument. And of course, we need to import delay.dart. And for consistency, I'm also going to copy this line and paste it in here inside the method to create a user with email and password. And now we can get back to our tests. And just like we did before, we can add a method that returns a fake auth repository, and we can call this make auth repository and use the arrow operator to return a fake auth repository with an argument of @delay equal to false. And then we can make sure that we call this method inside our tests. And now we are ready to add a test for our method to sign in with email and password. So inside here we can type test that current user is not known after sign in. And then we need to add the test body, and we are going to make this async because we will await inside it. Then we can create our auth repository, and we can await for auth repository.sign in with email and password. And here we could pass in any hard-coded email and password that we want. And then we need to write an expectation that auth repository.current user is equal to a certain value of type @user. And since we are going to write some more tests that are similar to this one, I think it's convenient if we define some constants that we can reuse. So let's go back over here at the top, and here we can add a const test email equal to a hard-coded value, along with a const test password as well. And we can also create a final test user, which is equal to an @user. And in order to use this, we need to import @user.dart. And when we create this object, we need to pass two arguments that will represent our expected value. And if we look at our repository, we can open the create new user method. And we can see that the UID is generated using this expression. So if we want our expectation to pass, then our expected value should also be calculated in the same way. And this means that over here, we can type UID equal to testEmail.split.
So he pointing out the create new user method where we say UID at email.split reversed and join. So we should do the same for UID.
.reverse.join and pass this test email as an argument like this. And now that we have all this test data, we can make sure that we use this test email when we call this method. And we should also use the test password like this. And finally, we can complete our expectation and pass this test user as the expected value like this. And now that our code compiles, we can try to run this test. But as you can see, we get a failure. telling us that we expected an instance of type appUser, and the actual value is an instance of appUser. So this is not really very helpful. But can you think of any reason why we are getting this failure? Well, the problem is that even though these instances of appUser contain the same properties, we haven't implemented the equality operator inside our appUser class. And this means that Dart cannot figure out how to compare two instances of this class. And as a result, the test will fail. And the way to fix this is that we should use the Dart data class generator to implement the equality operators, and we can also add a toString method for convenience. And now that we have this, we can try to run our test one more time. And as you can see, the test is now green. And just to be clear, the reason that this is now passing is that when we call this method to sign in with email and password, then we pass in these two arguments that we have declared over here. And as a result, this method will be called, which in turn will create the new user, and this will create an appUser object, which will be invoked with the same values as the ones that we use for our expected value in the test. And in practice, this means that these two objects are the same. And while we're here, we should also expect that AuthRepository.AuthStateChanges emits a test user, because the latest value that is emitted by this stream is always the same as the value inside the current user. And in fact, we can run this test and we can see that it's still green. In summary, the main takeaway of this lesson is that if you ever want to compare instances of custom data classes, such as the appUser that we have in this project, then you should always make sure that you implement the equality operator. And you should also implement the toString method, as this will make it easier to understand any failures in your tests. And the Dart data class generator gives you an easy way to implement this method. Okay, so let's continue on the next lesson, where we will add some more tests for this repository.
Okay, I'll stop for.
In this lesson, we are going to complete the tests for our fake auth repository, and we'll also learn a bit more about testing with streams and behavior subject. So let's continue where we left off. And as a next step, we need to add a test for this method to create a user with email and password. And since this is quite similar to the method above, then over here we can just copy this test and paste it in here. And then we can change the description to current user is not null after registration. And we also want to make sure that we call this method to create user with email and password inside our test. And at this stage, we should be able.
So, well, in part 2 on testing repository, what he said, like we are going to see, we tested one function sign in with email and password. Now we want to test this create user email password, which is very, very similar. So we just say after register, and the method will be create user with email and sign in instead of sign in with email. Yeah, let's read first. Test streams and emit multi-value in set artifact. Only observe those value if we start listening to the stream before they are omitted. There's one exception to this. Our stream is backed by behavior subject, and we will be able to after sign out. Okay. So we are using this emit in order to check the value that should be emitted. It won't work if we remove the exception after the call. This way of writing test is not very intuitive, so we can have multi-expect call at each. So this one will be testing for sign out, which looks quite a lot. But this function we already tested, which is in sign in and sign out. This one should be easy. But let's continue to listen.
Run the test, and as we can see, we get a success. And at this point, we could ask ourselves if we should write some more tests to check this method, depending on whether we already have a current user or not, since the create new user method is only called if current user is null. And this is a valid point, but I also want to point out that we are really unlikely to call this method when we already have a non-null current user. In fact, our e-commerce app will prevent us from even going to the sign-in screen if we are already signed in. And this means that it's reasonable enough to remove these if statements from this method, like this. And as a result, we no longer have any conditional logic to test, and I think that the tests that we have already written are appropriate. Though what I will say is that writing tests is always a good opportunity to revisit the code that we have already written and see if there are any edge cases that we haven't covered or if we can simplify our implementation.
So he means because we already implement to check if its current user is not in our UI, we already have code to check this. If it's not, user will not go to sign-in page, so they will not run this function. We will not call this function, so we don't need that if check. So, and to make the code cleaner, I will also delete that.
Next up, we can focus on the sign-out method. So let me remove these comments since we no longer need them. And in this case, we can write a test to check that the current user is null after sign out. So let's write this. And here we can add a test that says current user is null after sign out. And then we can add the test body and make sure to mark this as async. And inside it, we can declare our final auth repository. And I think that in order to make this test meaningful, we should first sign in. Otherwise, the current user will already be null by the time we sign out. So let's await and call authRepository.signing with email and password, passing the test email and password as arguments. And then we can call await authRepository.signout. And then we can expect that authRepository.currentUser is null. And we can also expect that authRepository.authStateChanges emits null. And now we can run this test.
Okay, cool. So this one, we can just copy this part. And so we are testing the current user is null after sign out. Although the sign out function is short, but we need to sign in first, and then we await for auth.signout. We expect this as null, and this one emit as also a null.
We can see that we get a success. And just to be clear, the way this test works is that we call sign in with email and password first, and this will ensure that we have a null user by the time we sign out. And only after sign out is complete that these expectations become true. However, you may wonder if it would be possible to check the various values that are added to this string, as you call these different methods. And the answer is yes. So if we wanted, we could modify this expectation and replace this with emits in order, which is a string matcher that takes an iterable with all the values that we expect to see in our string. So if we wanted, here we could try to type test user followed by null as values, since this is what we would expect to see after signing, and this is what we would expect to see after sign out. So let's try to run this test once again. But as we can see, we now get an error. And if we try to read this carefully, we can see that the expectation is that we get an app user followed by a null value. However, the actual value is a behavior subject which only emitted a single null value. And to understand why this is, we need to remember that streams represent asynchronous values that can change over time. And this means that if we check for old state changes after we have already signed out, then the only value that we will be able to observe on the string will be the latest value, because behavior subject is designed to remember its latest value. And as we know, the FakeAuthRepository uses this in-memory store that is based on behavior subject under the hood. So if we wanted to verify that this string emits more than one value, then we need to move this expectation.
Okay, is it clear? So basically, it's possible we are emitting a list of value. So we comment this one just for reference, right? And we can write emit in order function, which will take actually no, it will take a list with test user and null. So I'll add a dot notation. After sign in, and here after sign out. But this one actually fails, so we want to add a note. We are using behavior subject, which is not right, which emits only last value. So basically means if once we call this, the result will be null. We will not have the test user. So the following code will fail. But I think what we should do probably is here. Expect a user, test user, right? And then you sign out, then you expect a null, and this is wrong. Let's see what he says.
Before our call to the signout method, like this, because this way the string matcher will have a chance to observe the first value, which is set after we sign in, and then it will wait for the string to emit the second value, which only happens when we make this call to sign.
Last value.
Any method like that. Do you know the FakeAuthRepository uses this in-memory store that is based on behavior subject under the hood. So if we wanted to verify that this string emits more than one value, then we need to move this expectation before our call to the signout method, like this, because this way the string matcher will have a chance to observe the first value, which is set after we sign in, and then it will wait for the string to emit the second value, which only happens when we make this call to sign out.
Okay, I get it. So we can so we don't want this basically, right? What do we want? We want to test this function as a stream. We want to see the stream change, and so we are not going to use the image, but we use the here we already have an image. So let's sign out. We can try with the image in order. So user sign in, we get user, and then sign out we get no. Although the sign out function is later, what we expect is in the stream of value, the last value is saved after user sign out. I'm not sure why. And this one for current user, this is not a stream, so we just get a null. I can still leave a comment here, but
In fact, if we run our test once again, then we can see that we now get a success. And I have to say that this behavior may seem a bit counterintuitive, but if we keep in mind that streams emit values over time, then this becomes clearer, because we can only check these values if we can observe.
So check the value then should be omitted, emitted. The same code won't work if we move same execution after the sign out, because we will only get the latest value, which we will only latest value, then no, and not the previous one, right? Because behavior subject always give you the latest value. So we can have multiple expectation call at each step instead. Interesting. So basically, he said in this example we expect this latest value from here after signing, upcoming value from here, right? And then we call the method under test sign out, and you get no. But he said it's not very intuitive, so it's better we write each separately. I had tearDown, he will explain soon. So we sign in, we expect this. Then we sign out, we expect a null.
Over time. So this was a bit of an advanced tip, and overall I think it's not really worthwhile writing tests like this if we can avoid it, because they are not really intuitive. So let me remove this expectation altogether, and as an alternative it's a lot clearer if we add multiple expectations between calls. For example, we could copy these two lines from the previous test, and then we can paste them in here, since this is a good way to check that we get a test user after signing in. And then we can copy this line from here and put it over here and replace this value with emit null, like this. And this is how we can check that we get a null user after signing out. And if we run this test once again, then we can see that it's still green. Okay, so we are all done with the FakeAuthRepository tests, isn't it? Well, we can check this by generating the test coverage one more time. And as a result, we can see the updated coverage gutters. And if we scroll down, we can see that we have a red gutter over here on the dispose method. And in fact, this reminds us that we haven't written a test for this. And what we could test in this case is that if we attempt to sign in after we call dispose, then we'll get an exception because the string is already closed at that stage. So over here we can add a new test, and the description could be signing after dispose throws exception. And then inside the test body we can create our AuthRepository, and then we can call AuthRepository.dispose. And the next thing that we can do is to write an expectation, and we are going to use a closure with the arrow notation to check that AuthRepository.signing with email and password, passing the test email and password, and we want to check that this throws a state error. And at this stage we can run the test, and as we can see, this is now green. And if we go ahead and generate the test coverage again, then we also see that this gutter has become green as well. And in summary, this lesson has given us a more in-depth understanding of how to do testing with streams and behavior subject. And we have also completed all the tests for our fake auth repository. And if we open the testing tab, we can see that this is confirmed by our test coverage.
I think I'm missing something. Yeah. Why is it so small? Oh, here. Authentication. And product. We tested this already. Yeah, we don't need to test these. It's interesting. Why it says there's no. Okay, it's lower than 50. That's why. Because we don't have leave. That's okay. So okay, now I found out. At least we know where to look. That's the plugin to give us this coverage, which is neat. We're missing one more test than he has here, which is for the sign out. Dispose this function. He basically suggests we should change this into here, which I understand, but currently I don't want to do it, because just to leave a note, this one is similar than the one we have above, so we can leave this to learn a new function, right? That's why and it's working. That's why I didn't delete it, to give us a reference to learn different function. And then we have
completed all the tests for.
So another test we have is test sign in after disposal exception. Why do we test that? I have to go. I'll come back soon. Okay, so in the last session we added this function to test the auth if we call auth dispose, and then we try to sign in. We should get an error, and at that time, if the user, for the current user, it should be no. So and all tests passed, and we covered this test. That's basically this chapter is. So we are going to move to the section 12 on module 6 for mock versus fake. Install mocktail package. Okay, so we continue with
now that we've completed the unit tests for the repositories in our app, it's time to move on to something else. And I think what would be most interesting at this stage is to learn how to test our controller classes, since we have added the AccountScreenController and the email and password signing controller in the previous section. So let's start from the AccountScreenController, since this is the simplest one. And since this controller doesn't contain any UI code, then we can test it with some regular unit tests, just like we have done for our repositories. However, what is different about controllers is that they often depend on the repositories themselves. For example, this AccountScreenController depends on the FakeAuthRepository that is passed as a constructor argument. And if we want to test the behavior of the AccountScreenController, then we need some way to configure this authrepository so that it behaves how we want when we call this signing method on it. And in practice, what we want to do is to create a mock authrepository. And this bears the question, what is the difference between a fake and a mock? And the primary difference between the two is that a fake is a class that contains some limited capabilities, such as the fake authrepository that we are using as a replacement for the real authrepository that we will implement later. On the other hand, a mock is a class that can be configured to dynamically return values or throw exceptions depending on what we want it to do. And it also allows us to check if any particular methods have been called or not. And the bottom line of this is that mocks are particularly useful when writing tests, as they are more easily configurable than the fakes themselves. So how do we create a mock? Well, the main idea is that we can use an existing package, such as mocktail. And the way this works is that for any given class, then we can create a mock of that class. And then we can use a so-called stub to modify the behavior of certain methods and provide an alternative implementation instead. And then we can use the verify method to check if these methods have been called or not. And the mocktail package gives us many useful APIs, as well as some additional matchers that we can use to work with mocks. So as we make progress, we'll get familiar with some of these APIs, and as usual, you're free to explore the documentation if you want to learn more. So our next step is to go back to VSCode, and then we can open the command palette and select the option to add a new dev dependency. And the package that we want to add is called mocktail. And once we have done this, we can open the pubspec.yaml file, and we can see that mocktail has been added to the dev dependencies section. And what I'm going to do is force this version to 0.3.0, which is the current one as I record this video. And now we can continue in the next lesson, where we will start using this package.
Great. Install it. Complete and continue, so we are now moving to this one.
Now that we have installed the mocktail package, we are ready to write some tests for the AccountScreenController. And this means that we can select this file from the Explorer, and then we can choose this option to go to tests. And we can
So we go to presentation on account, account is authentication. Under account we have account controller. We don't need this. This is a controller, then take an argument for auth repository. So we want to mock this and test. I think we are testing this one with a new package. So we go to test. Yes.
Then we want to create a test file for this. And as usual, we can move this file to the right, and we can open the AccountScreenController.
Hey, and we split, but this one is not. So we put this open to the side. We can see more clearly. Really good. Maybe we don't need this for now. Sorry, I don't know how to remove this one. Oh, okay, cool.
The left. And then we can go to our test file and remove this default test. And then inside the main we can add a group, and we can call it AccountScreenController. And then inside it we can add our first test. So this is a good time to ask ourselves, what do we want to test? And just by looking at this AccountScreenController, I can think of 3 possible things that we could test. The first one is that as soon as we create the AccountScreenController, then the state should be set to async value.data with null. And the second one is that when we call the signout method, and the signout method from the repository succeeds, then the state will be set again to async value.data. And the third one is that if the signout method throws an exception instead, then the state should be async value.error. So let's go ahead and try to write these tests. So for the first one, we can type initial state is async value.data in the description. And then inside the test, we can create a final auth repository equal to FakeAuthRepository. And in order to use this, we need to import it. And then we can create a final controller, which is going to be an AccountScreenController, which takes the auth repository as an argument. And once again, we need to import this in order to use it. And at this stage, we should already be able to expect that controller.state is equal to async value.data with a value of null. And
sorry to interrupt. We should read it first. So it's missing a tab donation. We should write like this. Remember we did actualize when writing. Async data loading. I didn't know that. So use async loading rather than async dot loading. Async data rather than async value dot data. Breaking changes. Yeah, we will change it. to async notifier. So what I think we should, let me just comment it first. Auth repository. So let's take auth repository, send out async loading. And I just want to make a note. We can use async value subclass. Let's say notes. So we refactored into from list to the async value, but later we changed it back. The reason is type notation and type error during the test. Start from here. Why we have controller 2? This is the same, but it will change notifier. Ah, right. And I can move the old version. By the way, if you don't like it, you can just delete everything, right? So now it's cleaner. No. So we already start to expect this value as so how to write? We say group no, group account screen controller. No, not this one. So group account screen wait. So we don't have test widget because we are not testing widgets. So all we do is a test and so group account screen controller. And we are not testing this. What we are test initial state is a sync value dot data. It should be null. So here we see final auth repository equals FakeAuthRepository. And controller equals AccountScreenController. We need to import.
In order to use async value, we need to import Flutter Riverpod, and then we can save our file. And if we pay attention, here we get a notice telling us that the member state can only be used within instance members of subclasses of state notifier. And the way to address this is to use another property called debug state, which was explicitly designed to be used inside our tests. And at this stage, we could try to run this test. But as we can see, we get an error telling us that async data of type no with value no is not the same as async data of type dynamic with value no. So even though the values themselves match, it turns out that these objects have different type annotations. And this is because in the previous section I told you that we can omit the type annotation when passing an async value as the state class for our state notifier. And as we can see, now that we are trying to write some tests, then this is a problem. So I'm going to take back what I said before and propose that to fix this test, we need to add a type annotation to our async value. So let's add a void type annotation here. And we should ask ourselves if we should also add it here, and here, and here, when we assign the state variable. But this is not necessary, because in this specific case, Dart can infer that this state variable is an async value of type void, because this is how we have declared it over here. And this means that we don't need to add it explicitly in these three cases. However, we do need to use async value of type void when we declare our provider. And we should also use it in...
Here we should also add void, specifically why? What's wrong? Let me see. It's already getting error. We already have. That's weird. So we copied this. Right? It should be exactly the same. It does not know async value of void. What's going on? It was correct. I think maybe we have some version issue. Let me try to fix. Okay, I fixed. So what happened is we had two packages, report annotation, which we will start to use in section 13, and this one will use the generated code, which actually is a lot easier, so we don't have to worry about the type. But it seems the two packages get some conflict. It shouldn't be, but I don't know why it gets this conflict. So if I add report, so for all the async values that I'm using, I add report dots indicate this async value is from the Flutter report package, and then everything is working. So the main change is we want to add this void, async value void, so to specifically add type donation, even though the type is a dynamic, and then it will work everything. And you also need to add here when you claim the provider. But again, this way with the generated code is a lot easier and can avoid the issue. And in the test we had error. Now you can see it's passed because we need to fix it's again the same. So it was async value like this. It doesn't show any error, but if you run the test, it will have error, and to fix that you add void. It's very tricky. Yeah, so let's keep going
in the right places so that you get a better understanding about where they are needed. And by the way, before we continue, I want to show you a small change that we can make when we use async value. In fact, one thing that you should know is that async value dot data is the same as async data. And likewise, async value dot loading is the same as async loading. And this is also true for async error. And inside our test, we can replace async value or type void dot data with async data or type void. And the reason for this is that async data, async loading, and async error are all classes that extend the base async value class. And as a proof of this, you can open the documentation and check by yourself. And this means that we can use this syntax, which is a bit more concise. Okay, so let's continue in the next lesson, where we'll write the remaining tests for our controller.
So the next lesson will be this one. Yeah, we almost finished this section, so let's keep going. Before we play the video, as usual, I still like to go through and read. This is just some screenshot that I can delete, so I can make this a little bigger. Got a message. Okay. Anyway, so still recording. So we are testing the AccountScreenController part 2. This time we need to use the mock. Yeah, so far we haven't used. So this is how we do that. We pass the mock repository as argument because it implements the fake auth repository. By default, mocks implement all methods by return no. Stopping a mock to decide the response of a mock method. When something mock method, then return the answer, then through. If this is not what we want, we can stop each individual method. Here's a couple examples. When authority dot sign out, then answer, return a future dot value, throw exception, then throw verify a mock. Then we can verify if a stub method was called. Verify never. Oh, there's a lot of method here. We need to read more on this documentation. So here's how we do that. So we first create a repository. Again, we are testing this page. Everything the same, but we, instead of using our real repository, we use mocktail repository. Verify never. Sign out. Test sign out. Success. Async. To test, this is how we test sign out. Okay, I will copy these here first and stay and in the code. I will still leave this one here, although we don't really need this. Extend mock, here we need to import. Think we need to, oh, no, what's going on? Ah, it should be here. The class is out. Great. Of course we don't need this. So function initial state is .data. Instead, the first one we use auth as what we have in our code, because we don't have Firebase real user sign-in, so we are still using the FakeAuthRepository, which is our actual repository. And we are testing if before sign-in, if this is null, and it is null, and then we get a mock. Yeah, it can be very confusing. We get a mock, and the mock will be used as auth repository. Actually, I would like to rename it as mock auth repository. Otherwise, it feels confusing. Mock auth repository. And here is the same. Yeah, this is not too bad. See, it's more clear. Now here we set up, we get the instance, and we call the function sign out. The reason we have sign out is because, it doesn't return anything. It returns null from the package. Oh, from our side, but it mocks this one. So the mock will imagine this is a real auth repository, and it will have a sign out function. And when we create a mock from here, this class will also have a sign out function. That's what we call here. And we also get the controller that takes the mock one, which is this controller. It's a state notifier and this controller await sign out. We call this function, but the auth repository that inside this function is not the real one. It's a mock.signout. Yeah. Okay, I think it's clear. So this has verify never. Verify never. Verify a method on a mock object was never called with given argument. This one, we are still testing the initial data, so we don't call sign out. That's my guess. But this one we need to call, and called one. Sign out. When you sign out, it should be null as well. Okay, let's listen what he said.
We are now ready to write some tests for the sign-out method inside our controller. And as part of this, we will start working with mocks and learn how to use them in practice. So over here, we can add a new test called sign-out-success along with a test body, and we are going to mark this as async. And unlike what we had done here, where we created a fake auth repository and passed it to our controller, this time we actually want to use a mock auth repository, because this will allow us to do two things. The first one is to decide whether the sign-out method should return successfully or throw an exception when it is called inside the controller's sign-out method. And the second one is to check if this sign-out method is actually called. Okay, so let's see how this all works. And the first thing that we need to do is to go over here at the top and define a class called mockAuthRepository, which extends mock.
Wait a minute. The sign-out function he's using is different. Does sign out. So instead of this, we actually change to here. So what we can do is to add a void, so we don't need to return anything. Like this. Interesting.
And implement our fake auth repository. And we are going to open and close curly braces, since we are not going to implement any methods directly inside this class. And in order for this to compile, we need to import the mocktail package, since this is the package that defines this mock class. And if you're curious about what this class does, you can read the documentation, as this says that a mocked class implements all fields and methods with a default implementation that does not throw a no such method error. And it may be further customized at runtime to define how it may behave using when. Okay, so let's see how to use this mock auth repository in our test so that we can understand what it is all about. So over here, we can type final auth repository equal to mock auth repository. And then we can create our controller, just like we have done in the previous test, and pass this auth repository as an argument. And Dart will allow us to do this, because this AccountScreenController expects an argument of type FakeAuthRepository. And here we are passing a mock auth repository, which does implement FakeAuthRepository. And now that we have created our controller, we can await controller.signout, and we can also expect that controller.debugState is equal to async data of type void with null as a value. So this seems like a valid test to write, because here we call the signout method, and here we expect that the output state is async data with null, which is what we should get if signout is successful. However, we are not done yet, because while this mock auth repository does implement the fake auth repository interface, then all these methods will return null by default unless we configure it otherwise. In fact, if we try to run this test, we get an error telling us that we expected an async data with null, but what we got instead was an async error telling us that type null is not a subtype of type future or type void. And we got this error when calling mock auth repository.signout. And once again, that's because the signout method inside our mock repository returns null by default. And the way to address this is to stop the signout method. And we can do this over here by typing when. And here we can pass a closure that returns the auth repository.signout method. And by the way, this is the same as passing auth repository.signout directly as an argument like this, using a feature of the Dart language known as a method tearoff. And now that we have this, we can type dot. And here we need to choose between then answer, then return, and then throw. And I'll explain this method in detail very shortly. But for now, the one that we want is then answer. And as you can see, this takes a closure with an evocation argument, which we don't need. So we can replace this with an underscore. And here, rather than no, we should return future.value, which is a future that completes immediately. So once again, this is called a method stub, and its purpose is to tell the mock object what it should return when the signout method is called, rather than using the default mock implementation that returns null. And if we run this test now, then we can see that we get a green check mark. But in addition to checking the output state, there is one more thing that we can do, and that is verify that this method was actually called inside our controller. And we can do this by adding a new line that says verify that AuthRepository.signout is called one time. And if we run this test once again, we can see that it is still green. And just as a proof that this test is doing what it's supposed to do, over here we could try to comment out this line. And as a result of this, then both these checks are supposed to fail because we are no longer setting the correct state and we are no longer calling the signout method. So let me move this verify statement above the expect statement. And if we run the test again, then we see an error telling us that there were no matching calls. Because here we're trying to verify that this method is called once, but instead it was never called. And this means that in addition to calling expect to check if a certain value matches what we expected it to be, we can also verify if a certain method was called inside our mock object. In fact, the main difference between expect and verify is that expect is used to check some output state or variable, whereas verify is used to check the behavior of our class. And this is useful if we want to know if the methods of our dependencies are called or not. Okay, so let me restore this line of code over here. And I can run this test again just to make sure that it is still green. And before we continue, I also want to add some small comment called setup, run, and verify, because this can help us to clearly see how our unit test is structured. In fact, at the beginning, we do all the setup work by creating and configuring our mock. And we also create our controller, which is our object under test. And then we call the method that we want to run. And finally, we verify the results. So if you want, feel free to add these comments in your tests as well. And by the way, before we move on, I want to quickly get back to our first test, where we were only checking for the initial state. And what we can do here is to replace this fake auth repository with a mock auth repository. And if we wanted, here we could add an additional check to verify that AuthRepository.signout is never called. And if we run the test again, we can see that it is still green. And this confirms that the signout method is not called when the only thing that we do is to create our controller. And I just wanted to show you this. So that you know that you can use verify to check if a certain method is called a given number of times, and verify never to check if a method is never called. In summary, in this lesson we have learned about the fundamental building blocks that we need when working with mocks. And we have seen that if we want to mock a dependency, then we need to create a mock subclass that implements the type of the dependency. And we have learned that mocks always return no when any of their methods or properties are called. But usually this is not what we want, and instead we should use a technique called stubbing, where we can specify what happens when a certain method is called with certain arguments. And we
stubbing a mock.
use then return, then answer, or then throw, depending on the return type of our method. And finally, we have talked about the verify method. and see how we can use it to check if a method is called inside our mock. And I appreciate that if you've never worked with mocks before, this is a lot to take in, but I want to reassure you that we'll continue using them so that you get more practice and understand how powerful they are when writing tests. So let's continue on the next lesson where we complete the test for our account screen controller.
Great. Hello, let's continue. So we should start from Module 6, Section 15. And let's listen to the video.
We are now ready to complete the test for the account screen controller. And in fact, as a next step, we can implement a very similar test to this one. But this time we want to check what happens when the signout method fails. So to do this, we can copy this entire test.
So he's saying this is on account screen, so still account screen controller. Now we are testing account screen controller test. So we are testing the fan out function. Before we do that, let's read. When async.guard catches an error, it includes stack trace in the async error. We cannot compare state with async error directly, so this will fail because we can catch an exception but not the stack trace here. Instead, we have these two alternatives. We can check if the state has error as true, or we use a type matcher without checking the value. So dot state is I'm not sure. Okay, we need to check the documentation. And okay, so summary with the mocks. What we do here is we create a mock class for each dependency that we have. Okay, so such as FakeAuthRepository, and in each step call then return with the value, then answer 0 error. Once everything is configured, call the method that you want to test using await. Okay. Finally, verifying the result using either verifying this is a summary, so complete example. I want to read first and then type please. So we create a mock class, and for the month we group everything. So okay, we have everything grouped into one for this test, this screen. So first we test initial state. We get the repository controller and we verify never, and we expect the state is null. This means we didn't call this function because if you haven't signed in, you are not going to sign out. Now when you sign out, so we need to call the sign out function. After we called, then we also verify this code once, and the state value is null. Then sign out failure is something we are doing in the part 3. So this one, we get an auth with exception, then when auth sign out, then 0 exception. This is for setup final controller. So controller sign out means if you have a network error like this, the sign out will fail. So we will say, okay, we call this once, we expect it has error, and we expect the state is a async error. Okay, let's see how he explains.
And then we can paste it in here, and this time we can change the description to sign out failure. And then we can create an exception with a connection failed message. And we can modify this line so that rather than returning a future, we can call then throw, passing our exception as an argument, like this. And then we can still call the signout method and check that the corresponding signout method is called in the repository. And finally, we need to modify this last line, because this time we should expect an error. So what we could do in this case is to expect that our debug state is equal to an async error, which takes this exception as an argument. And we can remove this const keyword, like this. And then we can try to run this test. But as we can see, we get an error. And this time the issue is that while both the expected and actual value have the same type and the same error, the expected stack trace is null, while the actual stack trace is not null. And this is happening because asyncValue.guard will include both the error and the stack trace that we get when this method throws an exception. And we don't really have a way of creating a stack trace that we can use for comparison in our test. So in this case, I suggest that we make our life easier and modify this expectation to simply check that the bug state.has error is equal to true, like this. And now we can run our test again. And as we can see, we now get a green check mark. Since we are here, I also want to show you another way of testing this, and that is by typing expect.controller.debugState, and then here we are going to type is a, passing a type annotation of type async error and some open and close brackets. And this is a special type measure that we can use to check if a value is of a certain type. And here we can do this because async error itself extends.
Let's see. Let me get the code first, because in the video he said it's controller.debug state, and what we have here, this is our code. It's a state, right? His video, he said debug state. I'm just curious. If I say debug state, is it correct or no? Yeah, so it's wrong. So that's why so the video is older, but the text is newer. It's changed to this state, not debug state. I want to make notes about this dot in here. So verify. Okay, this will fail because and use just check if the state has error, or add a space. So the reason we read async error here is because earlier we read async data. So I want to make a note about what he said here as is a general type matcher, useful to check if a value is a certain type. Useful care about the value useful to check if a value is of a certain type. Very good. This is the notes on the video slide.
Value. So as you can see, there are various ways of writing expectations depending on whether we want to check the values themselves or their types. So feel free to use what you feel is most convenient in your own tests. And this completes all the tests that we wanted to write for our AccountScreenController. And the main takeaway of these last couple of lessons is that by using mocks, we have discovered a new way of writing tests. So let me share a step-by-step guide that you can follow if you want to write tests using mocks. And the first step is to create a mock class for each dependency that we have in our class under test, such as the FakeAuthRepository in this case. And then inside our test, we want to configure our mock and start all the methods that will be called when the test runs. And depending on what outcome we are after, we can answer with a value or throw an exception. And once everything is configured, we can call the method that we want to test. And then we can verify the results using either verify or expect, or both of them. And once again, we'll get more practice working with mocks as we make progress. Okay, so let's continue on the next lesson.
Cool. So next lesson, testing with stream matcher. I always find testing is a bit harder. So testing with stream matchers and predicts. Sometimes we want to test each individual state change inside of our state notifier class. An example of this is setOut function. Okay, when the state is set twice, loading and setOut. Tested by expect later before calling the code under the test, or using predict to add a custom timeout to ensure that our test fail fast when we need. What are we doing here? Okay. For a more complete overview of the topics, we read this article. Okay. And if desired, you can set the same custom test timeout for all tests in a given file. Add a class as his own articles. Notes about testing with listeners. Async notifier can be used as a replacement for state notifier. I've covered here. Right. Also, read this article for an alternative way for writing unit tests using listener rather than stream. How to unit test async subclass with Riverpod. Interesting. Looks complicated. So, do we have stream here? By the way, these are the new code that we will be changed to. This is the state notifier and setOut. AccountScreenController. Yeah, the rest are all the notes. Okay, let's.
In the last lesson, we have completed all the tests that are needed to verify that our AccountScreenController works as intended. However, there is one small detail that we haven't covered, and that is that in the sign-out success test, we have this expectation to check that the debug state is async data by the time this method returns. However, what we are not testing is that we also set the state to async loading as soon as we call this signout method. In fact, if we want, we can comment out this line and run the test again. And as we can see, we still get a success. So it would be good if we could modify our test so that it checks how the state changes over time. But this is...
You can't do by checking, okay. And that is why the signout has loading. Interesting, okay.
Something that we can do by checking the debug state, because this only gives us access to the last state value that was set. And one thing that you should know is that in addition to the state notifier also has a string property that we can use to check for state changes. So let's try to use it. And over here we can write expect that controller.string emits in order, and this takes an iterable that we can use to specify what state values we expect. So in this case, we expect to find a sync loading of type void first, followed by a sync data of type void with a value of null. And now that we have this expectation, we can remove this line because it is redundant. And then we can try to run the test one more time. But when we do this, we find out that it doesn't complete right away. And in fact, if we wait for 30 seconds, then we get a timeout. And if we want to understand this, we need to remember that streams emit values over time. Meaning that by the time we call expect, need to remember that streams emit values over time. Meaning that by the time we call expect, then the stream has already emitted both the async loading and the async data value. And so it is too late to check for this. And as we have seen earlier on in this section, the solution for this is to move our expectation before.
So here, let me write down the code here. After verify, okay, we want this to be called basically. How do I put it? So this is correct, but this one does not test the loading state. So this code does not works, but not testing loading state. If we remove this line, we will still get success. Test reload. Okay, cool. So we want to test. So this one is a stream matter, and okay, so hard. We want to test loading state and successful state. Okay, so what we do is we write the expect function. Expect. Oh, it's already right down almost. No. State. No. Controller dot string. Expect this string emit in order. What are they telling me? No. So actually it's correct. Emits in order, const loading void data void. No. Okay, so our Copilot basically give us same code as Android was saying, but I think if we run the test, it's going to be wrong. We will get error. And let's see it. So slow. So we see we get this. When send out, then I think he explained after a certain minute we will get some timeout error, you see. Timeout exception. Yeah. After this, and he will explain why. So this is, we expect this stream of async value. Oh, state notifier. Oh, so it create a broadcast stream controller and return the controller.stream. That's how you get the stream of T. Stream controller as this abstract class state notifier. Listener on error mounted. Okay. Update should notify. Testing. Okay, that's a lot. Let's listen.
The stream has already emitted both the async loading and the async data value, and so it is too late to check for this. And as we have seen earlier on in this section, the solution for this is to move our expectation before our call to controller.signout. So if we want to fix this test, we need to select these lines, and then we can move them up above this call. And by the way, one thing that I didn't mention before is that when we use stream matchers such as this one, we should use a special kind of expectation called expect later. And if we hover on this, we can find that this works just like expect, with the difference that it returns a future. In fact, emit in order is just one of many possible asynchronous matchers that we can use. And whenever we use an asynchronous matcher, then it's better to call expect later. And this carries more meaning too, because it makes it clear that we are expecting something to happen in the future after this call has completed. So if we want, here we can add an extra comment to remind us that we are expecting something to happen later. And as we have seen, if we are not careful, we can end up with a test timeout, because our asynchronous matcher keeps waiting for some stream values that never come. And in this kind of scenario, we want our tests to fail quickly, so that we don't have to wait for too long. And the way to handle this is to add an additional line at the end of the test. And here we can pass an additional timeout argument, which we can set to a timeout object, passing a short duration, such as 500 milliseconds. And this guarantees that our test will fail fast if the call to expect later hangs while waiting for this stream matcher to return. And using a timeout can save us a lot of time and money, especially if we have hundreds or thousands of automated tests that run on a CI system where we pay for the time that we use. And now that this test is complete, we can try to run it one more time. And as you can see, we now get a success. And next up, we can apply the same formula to the next test, which check.
Wow. Okay, it's a lot. This code will fail. Okay, let me stop for a while. I'll add some notes and then add the code. Okay.
And in this kind of scenario, we want our tests to fail quickly so that we don't have to wait for too long. And the way to handle this is to add an additional line at the end of the test. And here we can pass an additional timeout argument, which we can set to a timeout object, passing a short duration, such as 500 milliseconds. And this guarantees that our test will fail fast if the call to expect later hangs while waiting for this string measure to return. And using a timeout can save us a lot of time and money, especially if we have hundreds or thousands of automated tests that run on a CI system where we pay for the time that we use. And now that this test is complete, we can try to run it one more time. And as you can see, we now get a success. And next up, we can apply the same formula to the next test, which checks for sign-out failure. And to do this, we can select all these lines, and then we can copy them, and then we can move to the next test, and we can paste them in here. And then we need to modify this line, because here we are expecting an error rather than async data. So we can remove this line, and to do this, we can select all these lines, and then we can. If we have hundreds or thousands of automated tests that run on a CI system where we pay for the time that we use. And now that this test is complete, we can try to run it one more time. And as you can see, we now get a success. And next up, we can apply the same formula to the next test, which checks for sign-out failure. And to do this, we can select all these lines, and then we can copy them, and then we can move to the next test, and we can paste them in here. And then we need to modify this line, because here we are expecting an error rather than async data. So we can remove this line, and instead we could try to expect that we get an async error, a type void, with the exception as an argument. And we can remove the const from here as well. But as we have seen before, if we try to run this test, then we will get a failure, because the expected stack trace is null, which doesn't match with the actual one. So instead, what we want to do is to check if we have an error, just like we have done over here. And in order to do this inside an asynchronous method, we need to use a so-called predicate. And the way this works is that we can type predicate, passing the type of the value. And in order to do this
Okay, so we are using the same method to test sign-out failure, which we will also have two state change. So I'll just add this. So make sure to call this before the controller.signout. We can remove the comment. But in this time, we check loading and error, and the error will take it's not this one. The error will take an exception, which we already have, like this. I think toPosition argument. Okay, so the second one is no stack trace. I think when the video is done, there isn't a second argument for stack trace. So now that's why on the video it writes like this and does not throw error and the test fails. So now I think the API changed, and we can pass stack. So what do? Okay, let's say it's empty. Accept. Let's try it. Okay. And see if it's success or not. It failed because omics and events loading error. The actual is least when omitted is, so it failed. anyway, but it does not show any error in the code, which is very dangerous. Let's see how he explained.
On a synchronous method, we need to use a so-called predicate. And the way this works is that we can type predicate, passing the type of the value that we expect, which in this case is a sync value of type void, and this gives us a closure with that.
But he didn't explain.
Then we will get a failure because the expected stack trace is null, which doesn't match with the actual one.
Okay, the expected. Can we see stack trace dot null? No. What is this? This should be also wrong, I think. We can do again. Somehow this button's not working. Yeah. So, sign out failure. So he said, Utah async error will this code will fail. Well, we match section but not stack trace. Okay, cool. So we will remove that, and then he said we need to use the
Instead, what we
predict.
want to do is to check if we have an error, just like we have done over here. And in order to do this inside an asynchronous method, we need to use a so-called predicate. And the way this works is that we can type predicate, passing the type of the value that we expect, which in this case is a sync value of type void, and this gives us a closure with a value that we can write an expectation against. For example, here we can write expect that value dot has error is equal to true. And once we have checked this, then we can just return true, like this. And what is great about predicates is that they give us fine-grained control over the values that we want to test, meaning that we can still test what matters to us without worrying about the stack trace. And now that we have this expectation that we want to test, meaning that we can still test what matters to us without worrying about the stack trace.
Okay.
We can still test.
Okay, so we are using the stackcase with the type as async. I don't know why it's async value. Okay. But no. Async value of null, of void, and you pass by function. Actually, let's see if this is correct. It's a measure. This is right. This is but I. So what? This value, what he said is, okay, we call the value, and we pass, it's a function, and we pass a value, and we say expect as value dot have error, and the matcher is true. And of course and return true. So this should also work. I guess they both work. So this is not working. Oh, it's working actually. Yeah, you see we are running the test for both. That's a long time. We should also add a timeout, I think. So it seems yeah. Okay. So test sum out. Why it's not right? Oh, right. Okay, so either both, either this is this error or the one below will work. Okay. Okay, let's listen.
What matters to us without worrying about the stack trace. And now that we have this expectation, we can remove this line from here, and we can also add a timeout argument to the test. So let's copy this from here, and then we can paste it here at the end. And now that we have updated this test, we can try to run it one more time, and this time we get a green check mark. In summary, we have now figured out how to test each individual state change inside our state notifier subclass. And we have learned to use expect later along with advanced stream matchers and predicates to our advantage. And the main takeaway of this lesson is that when we test asynchronous code using streams, we can use expect later before calling the code under test. And we can use predicates to write fine-grained expectations such as this one. And we can also use a custom timeout to ensure that our tests fail fast when needed. And while the implementation of this state notifier subclass is quite simple, these techniques will work even if you have much more complex logic and multiple state changes and conditional logic. And by the way, if you go to my website, you can find this article that covers the same topics that we have just discussed in this lesson, and you can use it as a reference when you write your own tests. Okay, so let's continue on the next lesson.
Okay, that's great. Let's take a short break, okay?
We often have some setup code that is repeated across multiple tests. And in this kind of scenario, we can use a function called setup that will be called before each test. And if we need to clean things up after the test, then we can use a tearDown function. So let's get back to VSCode so that I can show you where we could use this lifecycle method. And a good example of this are the tests for our AccountScreenController. And as you can see, inside each of the tests that we have added, we always repeat the same lines to create a mock AuthRepository as well as our AccountScreenController. And we do the same thing here, as well as here, and here as well. And one thing that we could do to improve this is to initialize the mock AuthRepository inside a separate method that is called before each test is run. And to do this, we can use the setUpLifecycle method. So let me show you how this works. And the main idea is that inside the main function over here, we can declare a late mock AuthRepository, and the reason that this variable is late is that we can now add a setup method where we can initialize it, like this. And this means that inside our tests, we no longer need to declare this as a local variable, so we can delete it from here, because this is declared over here in the enclosing scope. And that means that we can remove it from here and from here as well. In fact, in this example, we could do the same thing with the AccountScreenController as well, by declaring a late AccountScreenController that we can initialize inside the setup method by passing the AuthRepository as an argument, like this. And this means that we no longer need to initialize it inside our tests. So we can remove this declaration from here, and from here, and from here as well. And just as a proof that everything still works, we can run the tests one more time. And we can see that they all succeed. And as I showed you earlier on, we can also define a tearDown method if we want to run some cleanup logic at the end of each test. And in addition to this, you can also call two additional methods known as setUpAll and tearDownAll. And the difference here is that these methods are called just once before and after all the tests have run, whereas setup and tearDown are called before and after each test. And by the way, you can choose whether you want these lifecycle methods to live inside the main method or inside a group, depending on whether you want them to run for all the tests or only for tests that live inside the group. So this sounds good, and in fact we have saved a bit of code already. But before you go ahead and try to move as much as code as possible into these lifecycle methods, I'd also like to make a counter argument against using them. Because by putting a lot of code inside them, you incur the risk of introducing some side effects, where some object or state may become unintentionally shared across different tests. And this can lead to test failures that are difficult to debug. On the other hand, if you don't use any of these lifecycle methods at all, then it's impossible for your tests to share any state, because each test has to create all the objects that it needs. And in fact, when I write my own tests, I try to avoid using lifecycle methods unless they are absolutely necessary. And we'll see some more examples of this as we go forward. So for the time being, we can keep the changes that we have made to this file, but just keep in mind that you need to be a bit careful when using lifecycle methods. And before we continue, I want to leave you with a little tip, and that is that if you want, you can add a tearDown callback directly inside each test. And just to show you an example where this is useful, we can get back to our FakeAuthRepository tests, and then inside each of the tests in this file, we can locate the line where we initialize the AuthRepository, and here we can add another line that says add tearDown with AuthRepository.dispose as an argument. And what this will do is to ensure that this method is called even if the test fails. So if we want, we can copy this line, and then we can paste it inside all the remaining methods, like this. And just to be clear, we could have accomplished the same thing by adding a setup and tearDown method where we initialize the AuthRepository and dispose it for each test, like we have done in this other file. So the takeaway of this lesson is that the Flutter test framework gives us test lifecycle methods such as setup, tearDown, setUpAll, and tearDownAll. But in general, we should use them with caution and try to avoid introducing side effects and shared state across tests. And we will see some more examples where using these methods is worthwhile later on. Okay, so let's continue on the next lesson.
Okay, so that's good. And he talked about tips about tearDown. Where is it's a bit too fast, I feel like. So basically, there are lifecycle method leads for, and he gave pros and cons on when to use each. And the downside is we may share state. That's what we don't want. But what we can do, this help us to, if you add this, you see, look, controller isn't used. Okay. It helps us to remove a lot of repeated code. So auth repository and controller. Why it said this isn't used but not this one? So it means we can just remove all these because they are the same. Yeah, here I used a different one, mock. Okay, I'll call all these as mock auth. Rename. And we don't need this. We don't need this either. It's probably the best to just delete it. Not, you see, just delete, not just comment, because we have a lot of commented code. So here we will say test method drawback. If you put lots of code inside test cycle method, you may introduce set effect where some object or state became unintentionally shared across different tests. It's impossible. So basically we can add a note. About tearDown, add tearDown. So sometimes you need to run some cleaned up code where a test has complete. For example, this one. This won't be called if the test is an exception. We say repository.dispose register tearDown. Current user is not now after sign in. So auth repository add tearDown means register this front will be called even if the test shows an exception. Where is this one? Test sign out. We don't have sign in. Let's see.
this method is called even.
Okay, it said this will be called even if the current user is, for example, we are testing initial state is async test FakeAuthRepository. It's not this test. He was testing added to this one. It's quick. I'm so confused. So where auth repository current user is no. Auth repository dispose. Where do we call the dispose here? Okay, is no auth repository expect current user. Okay, here we add a tearDown. Register upfront. This will be called even if the test fails. Then expect auth repository current user is no. Auth repository dot auth state changes emit now. Let's listen again.
And then inside each of the tests in this file, we can locate the line where we initialize the auth repository.
Okay, no. Let's read again.
And we'll see some more examples of this as we go forward. So for the time being, we can keep the changes that we have made to this file, but just keep in mind that you need to be a bit careful when using lifecycle methods. And before we continue, I want to leave you with a little tip, and that is that if you want, you can add a tearDown callback directly inside each test. And just to show you an example where this is useful, we can get back to our FakeAuthRepository tests, and then inside each of the tests in this file, we can locate the line where we initialize the auth repository, and here we can add another line that says add tearDown with auth repository.dispose as an argument. And what this will do is to ensure that this method is called even if the test fails. So if we want, we can copy this line, and then we can paste it inside all the remaining methods.
Okay. And after auth, so when we get auth, tearDown, dispose, right? Auth repository, tearDown. So the tearDown is before all the array method tearDown. Right, so we have 3 tests here. Oh, and here. This one has 2. Then after, let's see.
Like this. And just to be clear, we could have accomplished the same thing by adding a setup and tearDown method where we initialize the auth repository and dispose it for each test, like we have done in this other file. So the takeaway of this lesson is that the Flutter test framework gives us test lifecycle methods such as setup, tearDown, setUpAll, and tearDownAll. But caution and try to avoid introducing side effect and shared state across tests. And we will see some more examples where using these methods is worthwhile later on. Okay, so let's continue on the next lesson.
Can this run? Because after this point, sign in after this point, do we still also add a sign in here? Okay, that's fine. It seems it had no impact, but we have to expect current user is not after sign out, so state error. Another lesson for testing the email password sign-in controller with acceptance criteria. Let's see, testing with acceptance criteria. For non-trial test, we can write description as given how things begin, when action taken, then okay, test. Okay, given form type is sign in. When sign in with email and password succeed, then return true, and the state is async data. Let's start.
Now that we have completed the tests for the AccountScreenController, we can open the Project Explorer and move over to the email and password sign-in controller, which is a more complex state notifier
So we are doing the email password sign-in controller. Oh, testing is so hard. Okay, close lid. We move here. We test. So here we are in the email password sign-in controller. Where is that? It's also in the authentication folder. Sign in. I almost forget what this controller is about. This is a state notifier, okay. It has a form type. Let me review the code first. It takes 2 parameters. Why we need to take this sign-in form? Submit method state equals something stick. Yeah. Okay, loading and guard to authenticate. Okay, so that's why it takes form. So if the form is sign in, if the form type is sign in, we call the sign in method. Otherwise, we create user. Okay, I'm just setting up my iPad.
which is a more complex state notifier subclass that contains some conditional logic. And this is a good opportunity to get some more practice writing unit tests. And as part of this, we can also talk about acceptance criteria, which is a convention that is sometimes used when writing user stories that describe the interaction of a user with a product, along with the intended outcome. And when writing acceptance criteria, it's common to use a format known as given, when, and then. And sometimes I use this format when writing the description of my tests, since this allows me to see what the test is supposed to do. So let's go ahead and select this option to go to tests for this controller and confirm that we want to create a test file for this. And then we can move over to the right side and keep.
Okay. This one, go to test. is very handy. And this one we can split. Split, right. So we have controller and maybe you can leave me on the right side. You don't need to see it. Module 6. Okay, let's start it.
Original controller on the left side. And now we can take a look at this controller, and we can see that we have two different public methods that we can test, called submit and update form type. And for each of these methods, there are multiple test cases that we could write. So what I propose we do is to create a test group for each of these methods. So let's head over to the test file and delete this boilerplate code. And instead we can add a group with a description of submit. And for now we're going to leave it with an empty body. And we can add another group called update form type, also with an empty body. And then inside these groups, we can write our test cases. So let's try to write the first test for the submit method using the given, when, then format. And if we want to, we can put the test description inside a multi-line string. And inside it, we can type given that form type is sign in, which is how our test will begin. When signing with email and password succeeds, which is how the auto repository responds when we call this method, then return true, which is the return value that we get when we call submit, and state is async data, which is what we expect the output state to be. And then we can start writing our test starting from the setup code. And in this case, we're going to need the same mock auto repository that we had declared in the AccountScreenController.
Okay, this is very fast, so okay.
Called submit and update form type. And for each of these methods, there are multiple test cases that we could write. So what I propose we do is to create a test group for each of these methods. So let's head over to the test file and delete this boilerplate code. And instead we can add a group with a description of submit. And for now we're going to leave it with an empty body. And we can add another group called update form type also.
So sometimes ChatGPT give us very, just type yourself group submit a function. Okay, no, group called submit, which takes one function. Okay, and then another group for update form type. Okay.
Empty body. And then inside these groups, we can write our test cases. So let's try to write the first test for the submit method using the given, when, then format. And if we want to, we can put the test description inside a multi-line string. And inside it, we can type given that form type is sign in, which is how our test will begin. When signing with email and password succeeds, which is how the auto repository responds when we call this method, then return true, which is the return value that we get when we call submit, and state is async data, which is what we expect the output state to be. And then we can start writing our test starting from.
This is crazy. Very long. Oh. So inside submit, we write a long description for this task.
Code. And in this case, we're going to need the same mock auto repository that we had declared in the AccountScreenController.
So in AccountScreenController like this, we have this one where we can copy to here, because they both take auth, test, yeah.
Tests. So what we are going to do for now is to copy this declaration from here, and then we are going to paste it over here. And in order for this to work, we need to remember to import FakeAuthRepository as well as the mocktail package. And later on, we will move this to a separate file that can be imported and shared across tests. But for now, let's stay on track. And here we can declare some test values for the email and the password, like this. And then we can start writing our test. So inside the setup phase, we can create a final auth repository equal to mock auth repository, and then we can use when to define a closure that we.
So we also copy this test. It's a const. We don't actually have to put in the main, right? But it's okay. Doesn't really matter. So this one. Okay.
Used to stop the signing with email and password method when this is called with the test email and test password. And then we can type dot then answer and provide a closure that will return a.
No, dot and then answer will only apply when the method is called with the given argument. See lesson notes for more details. So this is the test method, which takes description and function body. And here, the function body, what we write is first as a setup. Oh, cool. Yes. And then we write something like when as a function. When so when auth repository dot sign in with email and password, then takes test email and test password dot then answer
future.value. And once we have this, we can create our controller, which will be an email and password signing controller, which we need to import. And this controller will take the auth repository as an argument and a form type of email password signing form type dot signing. And this is also something that we need to import. And then
answer to future.value. Okay. And then we get a controller. Equals email sign controller, which will take two arguments. One is auth repository. Wait. Okay. We need to form type is sign in. You see, it's very wrong, but anyway.
At the test run phase, where we can get a final result which is equal to await controller.submit with the test email and test password. And since we are using await here, then we need to mark our test as async over here. And finally, we can add the verification code. And here we can expect that the result is going to be true. And then we need to test that our controller emits an async loading state followed by an async data state. And we have learned that this has to be done by calling the expectLater method before we submit our controller. So over here we can type expectLater, that controller.string emits in order, and inside it we are going to add two values of type email password signing state. And the first one will have a form type of email and password signing from type.signin with a value of async loading of type void, like this. And then to create the second value, we can copy this code and paste it over here. And this time we can check that the value is a const async data, passing no as an argument, like this. And it's also a good idea to add a timeout of 500 milliseconds, like we have done in the AccountScreenController test.
Okay. So before we call this function, yeah, we need to ignore this because this is not correct. But we should import real part. And then, just like what we learned in previous lesson, we will do expect later. The actual will be controller.stream, controller and stream, and the matcher will be image order, which is a list, and so it has email. The first state, email sign-in state, form type sign-in value is loading. Then it's a data, then is a no. Oh my god, totally messed up. Okay, the thing is, it does not. I don't know what did I do. Okay, I accidentally deleted the code, but this is what ChatGPT was kind of recommended. But what's interesting is we are not using it, so should be value const async data type void. Oh no, async loading of type void. And here not this one either. It should be value async data don't know, but we need to add the type. Yeah, like this. We still have error. Where is the error? What's going on? So we are testing the group as submit, and we set up. This is crazy. Somehow we have 3. Test. Okay. Pin. And it should be this, and this is wrong. Oh yeah. Since this is a test of async, and we also we want to add a timeout. So milliseconds, 500. No. So should be here. All the parameters so hard.
And after we have written this code, we can try to run our test. And as we can see, we now get a success. So overall, this test is more complicated than the ones that we had written for the AccountScreenController. And this is because we had to write more setup code to stop the signing method and initialize our controller. But overall, we are following the same strategy that we used before. Next up, we can add a second test that we can use to check what happens when the signing fails. And to make our life easier, we are going to select the code for the entire tests, like this, and then we can copy it, and we can paste it in here. And then we can go back to the test description to say that when signing with email and password fails, then we should return false, and the state is async error.
Okay, so first, I'm just curious, how is our test? They run. Oh, Okay, it's passed. But if let's see if this is correct. So this is same error we get like in the last lesson where we already discussed. This is not correct because it's no. But I'm just curious if we see as while. Can we pass? Okay, that's a pass. So see, if you use this, okay, if we use this like loading without this void, I think we will get error. This is so tricky, so hard to test. Okay, that's a pass as well. Interesting. How about this one? What's the difference? Okay. So I'm just testing async value.data versus async data. Both no, but this one has a type notation. Emit in order. Expect later. So we expect a stream. This one is fine too. So we expect a stream in order with first state and second. Wait a second. So if we do this, is it we remove the void here? Let's see. Test. So in that case, it doesn't matter if you have the void type or not. I don't know why. But let's make a note saying like both the code works with or without this. Doesn't matter here. Cool. And this one, but this one, this code here must have the type void to work. Okay, because the state of value, the expected value is this one, so it must match here, I think. But for the stream above, the expected value expect later, so you expect later with actual matcher is all dynamic. So the string of type T has yeah, so in this case this is dot register. I think we are working on sign in, not register. Yeah, it's sign in. Sign in. Form type is sign in, but in this case it shouldn't matter. Let's do again. You have auth. Oh, wait. It matters. See, the immediate event sign value is null. So we are testing the submit function, which is here, and it can be form type. It takes form type to call the authentic. So sign in with email and password. Here is wrong. Sign in with email and password. Dot. But it works both. Sign in doesn't create. It gets different method. One less. Sign in with test email and test password, then answer. Color from type. Auth repository. We're calling this one. Create new user. So sign in and create new user. It's like same. with email. Let's try again. Yeah, it's a pass. Get into consistent. Sign in or create user.
Inside the test body, we can create a final except equal to an exception that says connection.
Okay, so now we are trying to test sign in failed. So what we can do is we select all the test code here, copy. Actually no, not good. It's still within the submit, but the test which is until here, I believe. See, this is one test, right? And we test another one, copy paste. And this test, we see the format sign in when the sign in with password fails, return a value of false. The state is async error. Okay, so here we have same auth. After auth, we create final. I'm so tired. Exception. Exception of equals exception which we want to throw is the exception in connection failed. Okay, connection failed. Listen.
And then we're going to change this method stub by calling then throw, passing the exception as an argument, like this. And then we can scroll.
Okay, so instead of then answer future value, we will call the then throw exception. Yeah, the exception that we just created.
And here we want to call this submit method just like we did before, but this time we want to check that the result is false.
Yes, of course, the result is false. Here we also need to, my guess is change this to dot error. Huh? Is that correct? Okay, I don't know what's going.
And finally, we can get back to this expectation. And just like we did before, here we can remove this value, and instead we can use a predicate.
Alright.
The type of this predicate will be email and password signing state, and this will give us a closure with our state object. And inside the closure, we can expect that state.formType is email and password signing form type dot sign in, and we can also expect that state.value.hasError is equal to true, and we can complete this predicate by returning true at the end. And this completes the code. And we can also expect that state.value.hasError is equal to true. And we can complete this predicate by returning true at the end. And this completes the code for our test. So let's scroll up and try to run it. And as we can see, we now get a green check mark. So this is good progress, and we have already managed to test some of the functionality in this controller. And this is a good time to open the terminal and generate our test coverage. So let's run this command.
Okay, let's stop for a while. I need to type the code.
Predicate by returning true at the end.
Okay, so here we, as before, we write predicate. Okay. Predicate. And we need to add a type. The type is email, password, sign-in state. That's the state we are testing. And inside this function, we have a parameter which is the state. And then we will call a function, and there's two expect. First we expect actual and measure. First we expect state dot form type. And we expect the measure. Typo. The measure is, you see, if ChatGPT is smart, it would give me all the right code, but it's not. Most of the time, it's not. Dot sign in. That's one function. Another one is expect state dot value dot have error. That's cool. Oh. Yeah, this is return true. This way here is hard to understand. What this return true means. And let's test. Oopsie, it's a fail again. Test data, let's see. Okay, before we do that, where is the issue? Loading. Maybe I should not have here. Yeah. Because we copied this code from before, so the expect should not be data, should be an error. So actually, if I change this to let's see here, async error. Oh yeah, remember the error will take 2 arguments and the stack trace is wrong. Stack trace is null and we cannot anyway, it's all done.
And this completes the code for our test. So let's scroll up and try to run it. And as we can see, we now get a green check mark. So this is good progress, and we have already managed to test some of the functionality in this controller. And this is a good time to open the terminal and generate our test coverage.
Cool.
So let's run this command, and as we
Flutter video is very fast.
test some of the functionality in this controller. And this is a good time to open the terminal and generate.
Okay, this is Flutter test dash coverage. Now you run it. Okay. This
Our
is
test
really
coverage.
cool.
So let's run this command, and as we can see, all the tests have now passed. And this means that we can watch the workspace to show the coverage gutters once again. And as we can see, we now have green coverage gutters for all the lines of code that we have tested. But we can also see that this line that calls this method to create the user with email and password is still red, because so far we have only tested the method to sign in with email and password. So let's continue on the next lesson, where we will complete the tests for this class.
Okay, let's continue. Okay, let's continue.
In this lesson, we're going to complete the unit tests for this controller and add test coverage for this call to create user with email and password, as well as the update form type method. And I should point out that the tests that we are going to write are very similar to the ones that we have already written. And the only thing that changes is that we should create our controller with a form type of register rather than signing. And this means that the easiest way forward is to copy and paste the two tests that we have already added and then modify them as needed. In fact, you should be able to complete all of this as an exercise using the things that we have learned in the previous lessons. So if you want, feel free to pause the video and try to complete this by yourself.
Okay, so I think we already done this because I did this is sign in fails. Sign in succeed and sign in failed. Right, so two tests, because originally we made it for for the create test. I think it's from here. Sorry. Let me make a note. Sign in. And here we do the register. Okay, so two function. Given the font type is, you can just, can you rename all the signal to dot register? Create new user, but here it should be dot, create user, create user with email and password, then answer create user, return when create user with email password exceed, return true. Somehow we have repeated. Let me see, did I? Okay, here sign in, return true. Okay, and the form type is dot register. So this is to get the controller, and here the sign-in state value. here the form type is also register and register, right? Yeah. Submit function is the same. Expect result as true. Code must be type void to make it work. Yes. And here, given the form type is register, so when create user with email and other fields, we want async error. So here it's the same when it's create a user with leave test data, it throws because we have an exception. So in this case, the form case is also register. So we get the controller.stream in the state. It also takes form type, which is a register, and here is register. Again, timeout here. Did we? I think. Oh yeah, we have these two. Okay, let's try to run it. It should pass. Okay, cool, it passed. So let's continue.
And now I can show you how to do it. So let's go ahead and select all the tests inside this group. So I'm going to select them like this, and then I'm going to copy them, and then I can paste them like this. And then we can scroll up to find the first one. And here we should modify this description to say that given form type is register, when create user with email and password succeeds, then we should still return true and the state should still be async data. And then inside the test, we should make sure that we stop this method and we should set the form type to register when we create our controller. And this should also be the form type that we expect to be emitted when we check the values inside our string. And now that we have updated this, we can save this file and run the test. And as we can see, we get a green check mark. And now we can move on to the next test. And this time the description should be given form type is register when create user with email and password fails. Then we should return false and the state should still be async error. So let's make sure that we stop the correct method inside our mock, and we should make sure that we use the form type with a value of register here, as well as here, as well as here as well. And now that we've updated this, we can run this test as well. And as we can see, we get another green check mark. And at this stage, we can open the terminal and update our test coverage. And you should see that all the tests have now passed. And as a result of this, we can see that this entire method inside our controller has a green coverage gutter. And if anything is not working for you, then make sure that you have updated all the right values in the right places. Finally, there is one thing left to do, and that is to test the update form type method. So let's scroll down to the bottom. And then inside this group, we can add a new test. And the description of this test will be given that form type is signing when called with register, then state.formType is register. And inside the test, we can do the usual setup and create our auth repository along with a controller, passing the auth repository as an argument with a form type of email password signing form type.signing. And then inside the run step, we can call controller.update form type, passing email password signing form type.register as an argument. And finally, we can verify that the controller.debug state is equal to email and password signing state with a form type of register and a value of async data of type void with null as an argument. And just to be clear, this time we can use a simple expect call and check the debug state property directly, because this method sets the state only once, and that means that we don't need to use expect later and check the controllers.
Okay, let's write Here update form. And we should write a test with something like this. Description and setup given the form is this time we call expect and check the debug state. No need to call expect later if the state update is only once.
Is equal to email and password.
No, let me just update form type, and say if it's a sign in, when called with register, the update is register. And so the setup is we get controller with auth repository, then form type sign in. We do not use expect later in this case. I think so. Just given the sign in, when form is sign in, when called with register. Then state.form type is state, then when called is register, then state form is register. Let's see. So no, the group will take a test. Like this.
Controller.update form type, passing email password signing form type.register as an argument. And finally, we can verify that the controller.debug state is equal to email and password signing state with a form type of register and a value of async data of type void with null as an argument. And just to be clear, this time we can use a simple expect call and check the debug state property directly, because this method sets the state only once, and that means that we don't need to use expect later and check the controller's stream like we had done in the previous tests. So let's run this test just to make sure that we've implemented it correctly, and as you can see, we get another green check mark.
Wrapped up.
reached the end of part 1 about automated testing.
Yay.
And when we started off, we talked about the testing pyramid and the difference between all these types of tests. And throughout this section, we have focused exclusively on unit tests, and we have seen how we can use them to test various classes and their methods in isolation. And in fact, we have been able to add test coverage to some of the repositories and controllers that we have created so far. And we have also learned how to use the mocktail package, so that we can mock dependencies that are needed by the objects that we want to test. And we have also learned about some of the test matchers that we can use to check if the result that we expect is of a certain type, or if a test throws a certain error. So overall, this section was about the fundamentals of testing in Flutter. And as we will see, we will build upon these fundamentals in the next section, where we will cover all the other kinds of tests. But for now, you already have the tools and knowledge that you need to add unit tests to your own apps. And in my opinion, adding unit tests is one of the best things that you can do, as they allow you to test all the most important business logic in your app, all the way down to classes and methods, so that you can check all the different edge cases. So if you're looking for an exercise to do at this stage, my best advice would be to go back to your own Flutter apps and see if you can add some unit tests using the techniques that we have covered. But of course, we are just getting started with automated testing. So let's continue on the next section, where we will build upon what we have learned.
Okay, great. Thank you. So let me see. So thank you so much for following. It's been a long journey, right? So you can see testing is really hard. It's very new for me, and we so far we only had code in the test in the auth and product data. So imagine if we build more features, and we will have a lot more tests we have to write. So it's a lot. So on the auth, just to review, we had this fake auth repositories. Actually, I don't want to change on the new branch. And presentation where we also have a controller test for the account controller test. That's also a very long file. And in sign-in, we have the sign-in test and the cross-product test. Yeah, that's it. Thank you. Let's so next video we will be looking for the test part 2, and we will cover the widget test and integration test, I believe, and then we will go back to other features, module 8, 9, 10, 11, 12, 5 more modules to go. Checkout flows, error handling, product reviews, product search is all features. And lastly, we update to report 2 with code generation. And that's it. Great, thank you. See you soon. Bye-bye.